प्रभात सर कौन है जॉइन करि परनाते हेलो प्रभात सर आपण श्वेतलीना को फोन करंतु श्वेतलीना आपण लिंक दे देबो अच्छा हो श्वेतलीना टिके प्रभात सर को लिंक दे दे Svetalina, are you listening me? Prabhat sir को link दे दे. Okay. May I request all of you, please mute yourself. All of you, please mute. Abhipsa, try to mute everybody. Okay? Yes. May I request our chief speaker to stop presenting, sir? Yes. Okay. Okay. It will like that. Okay. Very nice. Oh my God. Good afternoon to all the viewers on this virtual platform. Today's webinar, as you all know, space technology and Earth system science. May I request all of you, please mute yourself. Please mute yourself, all of you. It is an initiative under India Space Research Organization, that is ISRO. India, as you know, is a pioneer country so far as the science and technology is concerned. Everyone is curious to know about the space and its technology. During this pandemic, our objective is to explore the knowledge about the Indian Space Research Organization, the proud of India, which gives us an identity in the international level. Everyone is anxious, I know, to have a glimpse of ISRO. But why to visit during this pandemic? Let's invite the senior most scientists to make us around a trip, the space. So our webinar, as you know, space technology and Earth system science. The topic is. Today's chief guest of this webinar is our revered Vice President of our Scouts and Guide India, and also the State Chief Commissioner, Odisha State Bharat Scouts and Guide, Dr. Prasant Mishra sir. Our Chief Speaker, Professor Prasant Kumar Champati Rai, the Scientist G Grade Group and Head, the Geoscience and Disaster Management Group, Indian Institute of Remote Sensing, a faculty, a division of India Space Research Organization, and our President, Principal, Revered Principal, Dr.B.K. Kumar, Maharishi Degree College of Natural Law, and our Vice Principal, Dr. Aditya Prasad Samal, Maharishi Degree College of Natural Law, and me, the Dr.Namita Pattanaik, the Assistant State Commissioner, Odisha State Bharat Scouts and Guide, and also the lecturer in economics in Maharishi Degree College in charge of Rover and Ranger unit. And this, as you know, all of you, the Rover and Ranger unit of Maharishi College of Natural Law, in collaboration with Odisha State Bharat Scouts and Guide, and today, in collaboration with Physics Department of Maharishi College of Natural Law, are going to organize this beautiful program, this excited program, with the presence of all of you who are very anxious to see our guests. Now I request all our dignitaries to the Google board. Now to welcome all our viewers and also our guests, may I request my ranger, the IIT student Avipsa Parida, to present bouquet virtually. Over to Avipsa.
Thank you, ma'am. Good afternoon, everyone. Hearty welcome to everyone. How can a program start without offering bouquet to our beloved guest? So let's start with the bouquets. Welcome, sir. I welcome you to the Google board with a bouquet of flower. And as always, you have become our guiding force and do guide us always, sir. I welcome you to the board.
Thank you,
Next,
Avisa. Thank you.
then how can we start our program without our chief speaker? So let's welcome a hearty welcome to Dr. Prasant Kumar Champati Rai, sir.
Namaskar to all of you and
A
good
hearty
afternoon.
welcome to you, sir. It's my pleasure to welcome you to the board. It's really an honor and pleasure for me to welcome you to the board and welcome to our webinar. Then we can start our program without our guests. Just a minute. Now I want to welcome the president of the webinar, and always he has become always the backbone of our every webinar. He is none other than the principal of MCNL, Dr. Kumar Barik, sir. I heartily welcome you to the Google board. There is a flower bouquet for you too.
Thank you, madam.
Once again, I welcome you too to the Google board. And
Thank you.
obviously, I welcome all the worthy participants who are over here. Without you, we are just incomplete. So thank you for being with us and be with us till the last. I would hope this for all of you and welcome you all. I also welcome our Vice Principal, Dr. Advait Prasad Samal, sir. I welcome you, sir, to this Google board. Over to Namita, ma'am.
Thank you very much, Abhishek. I'm really happy that one very good virtual welcome is done by one of our arrangers. Thank you very much. Now, it's our proud privilege to ask my permission from my principal to start the program with Scout Guide prayer. May I start the
Thank you.
program, sir?
Thank you, madam. You are allowed.
Thank you, sir. Now, please,
Ma'am, let's have prayer.
all of you, please be in silence. We'll have Scout Guide prayer. Sadhan.
बैठे बैठे साहब
साफ बैठे बैठे सावधान.
दया कर दान भक्ति का हमें परमात्मा देना. दया करना हमारी आत्मा में शुद्धता देना. हमारे ध्यान में आओ प्रभु, आँखों में बस जाओ. अंधेरे दिल में आकर के परम ज्योति जगा देना. बहा दो प्रेम की गंगा, दिलों में प्रेम का सागर. हमें आपस में मिलजुल कर प्रभु रहना सिखा देना. हमारा कर्म हो सेवा, हमारा धर्म हो सेवा. सदा ईमान हो सेवा, वो सेवक चरण बना देना. वचन के वास्ते जीना, वचन के वास्ते मरना. पिता करना, प्रभु हमको सुखा देना, दया कर दान भक्ति का हमें परमात्मा देना, दया करना हमारी आत्मा में शुद्धता देना।
Thank you. Thank you, Abhi sir. Good afternoon to all of you. Today, although Abhi sir has distributed very nice flower to our dignitaries on the Google platform, but there are some silent workers in the background, in the backside of our program. They are none other than all my office bearers, staff members of Odisha State Bharat Scouts and Guides, starting from the State Organizing Commissioner Guide, Mrs. Namita Das, and Joint State Secretary Mihir Pattanaik, and all the office staffs, and along with all the office bearers, teaching and non-teaching staffs of Maharishi College of Natural Law, without whom this program could not have been possible. Now, over to my esteemed principal, Dr. Kumar Barik, the source behind all this webinar, and my esteemed principal, the president, not only the president, but the guiding force behind this program. So I now request our sir, Dr. Kumar Barik, to welcome officially to all the dignitaries and all the viewers virtually, sir. Over to Dr. Kumar Barik.
Thank you, madam. Very, very good afternoon to each and everyone present in this webinar. Respected Dr. Prasant Mishra, National Vice President, Bharat Scouts and Guides, State Chief Commissioner Odisha, the chief guest of this webinar. Respected Dr. Prasant Kumar Champati Rai, Scientist G, and Group Head, Geosciences and Disaster Management Group. Dr. A.P. Samal, HOD Commerce, and the Vice Principal of Maharishi College of Natural Law. Dr. B.N. Das, HOD Economics, the Administrative Bursar of MCNL. Dr. Namita Pattanaik, Lecturer in Economics, Maharishi College of Natural Law, and the Assistant State Commissioner, Bharat Scouts and Guides. The convener of this webinar, Mr. Manoj Kumar Mansingh, PT, Ranger Rover, Leader of MCNL, esteemed faculty members of Physics Department, and all other esteemed participants. I extend my hearty and warm welcome to all of you on behalf of my students and the staff members. At the outset, I would like to thank Dr. Namita Pattanaik, the convener of this webinar, who has taken a lot of initiative and effort to organize this webinar on behalf of Rover and Ranger unit of our college in collaboration with Odisha State Bharat Scouts and Guides and Department of Physics MCNL. I would also like to express my sincere thanks and gratitude to Dr. Prasant Mishra, who has given his kind consent to grace this occasion as a chief guest and deliver his inaugural address. Since the beginning of pandemic, he is always with us and has encouraged to our students and staffs in almost all the
Bharat Scouts and Guides. Under his vibrant and efficient leadership, Odisha State Bharat Scouts and Guides have achieved remarkable progress. We are extremely happy to have him in this webinar as a chief guest. I am also very grateful to Dr. Prasant sir, who has accepted our invitation to grace this occasion as the chief speaker and agreed to deliver on the topic Space Technology and Earth System Science, in spite of his busy schedules and other assignments. He is a motivational speaker and do expect that he would definitely enlighten and motivate to all our participants about the space technology and earth system science. We extremely feel proud and delighted to have him in our occasion. So nothing more to add. Once again, I extend my hearty welcome to all the distinguished guests, esteemed dignitaries, invitees, and all the participants on behalf of my students and staff members, and wish the overall success of this webinar. So thanks to all.
Ma'am,
Then
you
I
are muted.
request Dr. Namita Pattanaik, the convener of this webinar, to carry on this program.
Sorry. Thank you, sir. Thank you very much. Now, as you all know, we are having a constant source of inspiration with us. He is none other than our Vice President, National Headquarters, Bharat Scouts and Guide, Dr. Kali Prasad Mishra sir, who is very well known to all of us, but he may be very new to our chief speaker of this afternoon. As you know, sir, only for the knowledge of Dr. P.K. Champati Rai, I would like to introduce our Chief Commissioner of Odisha State Bharat Scouts and Guide, who has been since last 45 years serving this Odisha State, not only as the Chief Commissioner of Odisha State, but also the Vice President of National Headquarters Bharat Scouts and Guide, and he is a guiding force, a philosopher, a friend for all the union territories and all the revenue states in India. He is also the member of Asia Pacific region and the WORDM, that is the World Scout of the World Organization of Scout Movement. He has represented in India in many world jamboree, like 21st Jamboree at London, then in Asia Pacific region at South Korea and Philippines, and many more in SAARC countries. So I just like to say about sir, you might be knowing in the year 1998, Odisha State Bharat Scouts and Guide for the first time in the history of Odisha organizes not only in national jamboree but also an international jamboree, that is third SAARC jamboree, and where we have got 40,000 scouts and guides, and they have stay over for 15 days in near Baruni, and free of cost. They have given the free fooding, free lodging, and free boarding, and they have been given a chance to visit Puri, Kunar, the triangle, that is Nanankanan, and all that. This is only possible due to his leadership, and for his dedicated life, his dedication to scouting, the then president in the year 1990, 1998, and 2000, 2010, many times he has been awarded with different, the then president of India as received the Silver Elephant, the highest award for social service in scouting, which you can just well imagine just looking at the backside of all the certificates, all the honor he has been crowned by different presidents. And to the best of my knowledge, I could get a chance to work under his leadership, and I have represented at least 12 countries, and he has sent me to represent not only Odisha but also in India in various occasions, and in USA, in UK, and in all the Western countries, all that thing. The thing is that his leadership is such a beautiful way he guides us. He always asks us, just go ahead. I'm always behind you. That is the support he has given us, for which I could have organized during this pandemic 15 number of webinar. So I'm really proud of you, sir. I'm really proud of you. Hats up to you. So long as you are there, Lord Jagannath is there. We feel that our Lord Jagannath is there, and direct incarnation of Jagannath, as he is from a man of Puri. And he has been associated with many organizations, sir, like he is the Director General of Kalinga Sanskruti Odisha, Director General of Indian Society of Social Welfare and Rehabilitation, then the Chairman of Sishu Vikas Cuttack, and very recently he has been working a lot for the freedom fighter successor organizations. And to the best of my knowledge, he has been awarded with many decoration, that is Scout Jyoti, Scout Sri, and so many awards from different organizations within the India and outside also India. So we are proud of you, sir. Thank you very much, sir. And we are also happy to be here to you in this occasion to not only bless us but also to guide us, sir. Thank you very much. And now another person from Puri. All of you, you are very excited to see a scientist, G-grade scientist, the senior most scientist from ISRO, Dr. Prasant Kumar Champati Rai, with a postgraduate and PhD degree from IIT Mumbai, India. He has MA and PDF from University of 20, the Netherlands QS 186, is actively involved in research, education, training in the field of application of remote sensing, global navigation satellite system, and geographic information system in geoscience, geohazards, and planetary geology following on Earth system science approach. His current interest includes landside hazards, modeling, and early warning, that is warning that seismic hazard, that is earthquake, the assessment, the earthquake precursors and studies using total electron content, that is TEC, in ionosphere, geodynamics, and using global navigation satellite system, synthetic aperture radar in the Himalaya, that is SAR. He, along with his co-worker from India and abroad, has published over 85 papers in reviewed journals and around 170 papers abstract in other forms of publications. We are really grateful to you, sir. He has served the SARC disaster management that centers as head during 2008 and 2009. And besides that also, he is a member of several expert committees set up by ISRO, Government of India, and UN agencies. Besides, now, currently he is the scientist G-grade and group head, Geoscience and Disaster Management Studies group with 2 departments, that is Geoscience and Disaster Management Science at IIRS, Dehradun. So, regarding our chief speaker, it is nothing more to say, but it is more privilege on my part to introduce as one of the Bharaputra of Odisha, I can say, and blessed son of the blessed father and the blessed son of this soil from the earth of Jagannath ji, that is from Delango. His real home native place is from Delang. As I talked to him very just few minutes before, he was very spontaneously and very happy to introduce that, yes, I am from Puri. And I know any person from Puri, they are always blessed with Lord Jagannath, like our Kalisa. So thank you very much. Now, it's my proud privilege to request our chief guest and chief speaker to join with us virtually in the inaugural ceremony. Over to Abhisha for inaugural.
I welcome you, Kali Prasad Mishra sir and Prasant Kumar Champati Rai sir to inaugurate the program with our virtual inaugural ceremony.
তুমি অনন্ত অক্ষয় হে জগন্নাথ, তুমি অব্যক্ত অক্ষর হে জগন্নাথ, নিজ ইচ্ছারু সৃজি ମିଳସି ସ୍ମୃତିରେ ନୀଳାଚଳ ତହିଁ ବିରାଜିତ ବରରେ ତରୁ ବ୍ରହ୍ମ ରୂପେ ହେ ବିଶ୍ୱ ପାଳନ ଉଡ଼ା ପତାକା ପତିତ ପବନ ସଂସ୍ଥାପିତ ଭକ୍ତଗଣ ତୁମେ ହୋଇଛ ହେ ନାଥ। ଶ୍ରୀ ଜଗନ୍ନାଥ ଶ୍ରୀ ଜଗନ୍ନାଥ ଜଗନ୍ନାଥ ଶ୍ରୀ ଜଗନ୍ନାଥ ଶ୍ରୀ ଜଗନ୍ନାଥ।
Thank you, Abhisa. Thank you very much. In this auspicious day, we are also having the cooperation from the Department of Physics. I should remember, or I must be obliged to them, like Dr. Saswati Samant, the HOD of Physics Department, our Dr. Rajkishore Mishra, the NAC coordinator, along with the alumni of Physics, Rashmi, and all the students, ex-students, former students of our college of Department of Physics, and credit goes to one of my favorite students, that is Mr. Abhijit Mishra from Puri, residing at Puri, who has given technical support to me yesterday night till 2 p.m. Thank you very much, Abhijit.
Ma'am,
now,
we have Horace sir here, over here.
Oh, I see. Okay. I'm also, yes, very nice to see Haraprasanna Das sir, one of our guests in one of the webinar. He is a very talented person, and he always try to be in youth, because he was a youth, he is a youth, and he will be a youth. Welcome, sir. You can present a bouquet to her, sir.
Sure. Thank you, sir, for accepting my request and being here with us. I do want to welcome you too with a flower bouquet.
ଆନନ୍ଦର ସହିତ ହୃଦୟର ସହିତ ଶ୍ରଦ୍ଧାର ସହିତ ଗ୍ରହଣ କଲି ଆନନ୍ଦର
Thank you so much.
ମୁଁ ସେଦିନ କହିଥିଲି being connected, you proved what is the meaning of being connected. Great salute to Namita and salute to Abhisa. Though I have another international webinar that's going on in my tab, but you told me join, so I said no. I cannot say no. Prabhu Jagannath kari karau thai muhi mobinna ne kate. God bless you. बहुत अच्छा.
Thank you so much for being with us.
Continue.
हर साथ
Sure.
हमें हर साथ धन्यवाद तो निश्चिंत दबा धन्यवाद कर गोटी मात्र माने आपण जेते हमको ब्लेसिंग दे परिबे, but it is only possible for one person, one leadership, that is our principal and Kalisa. Without them, we are not able to go anywhere. So always they are in our left and right. That they are always with us, and I am really obliged to them. Now you will be happy to see. I am excited, really excited to introduce all of you, those who are joined virtually. One of my old friend. We are just classmates. We are reading in +2. You are reading +2 science. We are at that time ISC science intermediate, and one of such friend for whom I am really, really very much happy, very much proud of you, my friend. He is none other than our chief speaker, Dr. Prasant Kumar Champati. I am really happy. Now I welcome our Chief Commissioner, sir, Odisha State Bharat Scouts and Guide, our chief mentor, to bless us through his inaugural address. Over to Dr. K.P. Mishra, sir.
Namaskar. Am I audible?
Yes, sir.
Respected Dr. Vijay Kumar Barik, Principal Maharishi College and President of this webinar, Dr. Prasant Kumar Champati, a very senior scientist of ISRO, Dr. Advaita Prasad Samal, Vice Principal of Maharishi College, Dr. Haraprasanna Das, and Dr. Namita Pattanaik, Convener of this webinar, Assistant State Commissioner of Bharat Scouts and Guides, Manoj Babu, Robo Leader, all members of Physics Department, all students that are sitting, I can see them, Dr. Saswati and others. Respected all participants of this webinar. Good afternoon to all. As once our former President of India, Sri Abdul Kalam, said, if Indians are to play a meaningful role in the community of nations, they must be second to none in the application of advanced technology to their real life problems. All Indians, we are all proud of ISRO, Space Technology, Indian Space Research Organization, Bharatiya Antariksha Anusandhan Sangathan. This is an organization under the Department of Space, which is directly report to Prime Minister of India to perform tasks related to space, besides space application, space explanation, space exploration, and development of related technologies. We have heard about first satellite Aryabhata, which was launched by Soviet Union in 1975. After that, ISRO have produced so many navigation systems, Rohini, Gagan, Chandrayaan 1, Chandrayaan 2, many more. Bollywood has prepared a film on satellite sent to the Mangal, once founded by Sri Vikram Sarabhai, nurtured by great scientists like Abdul Kalam. This organization has grown day to day. Today, we have Dr. Prasant Champati, who is a very senior scientist of ISRO, who will enlighten us regarding ISRO's space science. Thank you very much. I thank particularly Mr. Vijay Kumar Barik, Principal of Maharishi College, who has patronized all these webinars all these days, and now he is planning to leave us. He is planning to leave Maharishi College, but not scouting. Once a scout, he is always a scout. He was a scout when he was the patron of Maharishi Natural College Rover Ranger team, and he will be always a scout with scout organization. Mr. Barik, well, I don't think you will allow us to feel sometimes that we are missing you. Thank you very much. I thank Namita and others who are managing this webinar. Namaskar. Thanks to all.
May I now request Kalisa to present the bouquet on behalf of the webinar memento to our principal, sir. Do you allow me, sir?
Yeah, allowed.
Okay, Abhip, sir, can you please share?
You are also allowed to physically present this to your principal.
Yes, sir. Definitely.
I heartily welcome Kali Prasad Mishra sir to present a memento to our president, our backbone. He would ever be our backbone. He won't leave us. We won't allow him to leave us. So let's honor him with a memento.
Welcome. Nakale madhyam ho jayegi teri.
On behalf of Odisha State Bharat Scouts and Guides, we are presenting this memento to our beloved principal, sir.
Our very dearest Dr. B.K. Barik sir, Principal, Maharishi Degree College of Nursing.
Thank you, madam. Thank you, madam. Thank you, sir.
Without whom this webinar will have a full stop, sir. Yes. Now, all of you might be very much interested to listen. Already we have covered 1 hour, but we must listen. I am astonished that till now many members are joining. I don't know what happened to them. Anyhow, they are very much interested. So India decided to go to space when Indian National Committee for Space Research was set up by the Government of India in 1962 with the visionary Dr. Vikram Sarabhai at its end. INCOSPAR set up the Thermo Equatorial Rocket Launching Station at Tiruvananthapuram for upper atmospheric research. We know. But henceforth, what happened? What is going to happen? And what has been done? I will not say. It will be listened from my friend and our today's chief speaker, Dr. Prasant Kumar Champati sir. Now I request to Mr. Champati sir to address the gathering. Over to Mr. Champati sir.
First of all, big namaskar to all of you. Very, very good afternoon, and thank you very much for giving me this privilege and the honor to present you my thoughts on the Earth system science and space science and the galaxy. Speakers and learned people they have logged in. I am very, very grateful and thankful to all of them for their time and their interest. So this is one of the most important motivating factor for people like us in ISRO to work further to the basic need of the mankind and the specific need of the people of this country. And that is what the Vikram Sarabhai stood for, that in the space science and application, we should not be second to anyone in solving the problem of the common man. So the space science in India is for the common man. So this is the Mula Mantra, Space Science Program India Day. And we all are driven by that and very, very passionately with lots of positive enthusiasm in spite of all the troubles what we face from the external world, also the internal system what we have in the country. All of you know that. But in spite of this, nothing holds us back when we try to do research in the frontier areas of space technology and its applications. This is one area which you have to explore. There is none who can come and help you. And this is something like swimming, that you have to really take a dip to learn the swimming. To the छोटे पिला मैंने logged in, they have logged in, and तांको मैं just small advice that space science is like swimming. You have to be, at the forefront. You have to be deeply involved in that to do something. And it's very, very important to know that it's not very difficult. That with some effort, very, very concentrated, conscious effort, you can contribute significantly, because the area is, the field is so vast and there are so many areas which are not yet explored. So enough opportunities there to discover something new. That is also another important thing, that don't think that all the scientists who have got the Nobel Prize, they have discovered everything. What is left to us people from Odisha, we can contribute. I will show you at the end of my presentation, there is still to discover, and we also have some experience of discovering some new things, and the pleasure of getting that, the satisfaction what you get, and the responsibility what is given by the countrymen, how you fulfill the responsibility, how you enjoy, and that is what the Bharat Scout actually teaches. And there is one thing from Bharat Scout, which I will tell during my presentation, that, they have a mantra. It is something like stay ready.
Oh,
So always
be
you should be prepared, stay
prepared.
ready, be prepared. And that is the thing is very, very important in the disaster management. I always present to my, to audience about the concept of be prepared. If you are prepared, then saving life and property becomes much more easier than before. So this is a small thing and a very, very, it may be a small thing to the people who are involved in the Bharat Scout, and but it's a very, very big thing for us who deal with the disaster management, where saving life and saving property is a topmost priority. So at the one front, at the one side, we are looking at the frontier technology, the space science, and other side we try to save somebody's life and property. So it's a very complex game, and you have to be 110% committed to the job what you are doing, and then you get the enormous amount of pleasure and the satisfaction and recognition, like what you, the nice words you spoke. I do not deserve that much. It is all my team effort. There are around 50 people working with me here, and there may be, another 50 people working abroad with whom I have worked. So all that culminated in certain things, and which I am going to present this 1 hour time. And let me just share my slides. And I should not forget to acknowledge the presence of the learned people here whom I just came across, and Dr. Kali Prasad Mishra ji. Big namaskar to you, and I am very much indebted to this organization you have been serving so passionately and achieved enormous amount of success in Bharat Scout and Guides organization. It's really we are all motivated, inspired by your contribution, and the college principal Dr. B.J. Kumar Barik. And I heard from Namita about your contribution and making this webinar series. It's such a big effort, and I don't feel like it's online. I feel like it is actually in person. I'm attending this, and the innovations you brought in, but and Dr. Namita, a lot of innovations you have brought in, and this COVID has taught us to be much more innovative, and that is what demonstrated during your inauguration. So I'm very, very thankful to all of you, and Dr. Samal, and also for all your support and your presence here. So I should not forget my college mate, Dr. Namita. She is the one who is full of enthusiasm and encouragement, and all the time talking to me to encourage me to deliver a talk and interact with the young students, which I am always always dedicated to. So thank you very much for connecting me and my friend Chandan, who might have logged in, who connected me to Dr. Namita. That's how we came to know each other recently after leaving our college days in 1981-83. So it's a happy reconnect with some of you at least, and knowing new people. It's a pleasure, and such a dedicated and also the talented people who have made enormous contribution in the field of education as well as service to the society. I'm really grateful, and let me start sharing my thoughts, sharing my presentation. And okay. So are you able to see the presentation?
Yeah.
Okay, now it's a full screen mode. You can
Oh,
see. Are you able to see
yeah.
the full screen?
Yes. Yes, I can. We can.
Okay. Right. Let me just go to the presentation, because on my screen it is not coming. And just okay. I hope oh, there is some issue. Let me just see.
It is shared.
No, are you getting the complete slide or?
Yeah. Yes, it is here.
ଅନ୍ୟମାନେ ପ୍ରେଜେଣ୍ଟେସନ ବନ୍ଦ କରନ୍ତୁ, ଜଣେ ଜଣେ ମଝିରେ ବର୍ଷା କିସ୍ ହେଲେ କରେ ପ୍ରେଜେଣ୍ଟେସନ।
Yes,
No,
sir. We are able to see. We are able to see.
We need to pick up that Champati rice. You can see the things very clearly. Her presentation is with us.
yeah,
Yes.
this should be correct. Yeah. Right. So you must be getting the full screen, right, in presentation mode.
Okay.
Yeah, are you getting?
Yeah.
Yeah.
So should I make it full screen? Yeah, it is coming. Oh my God.
Just to like someone is there, kindly please stop presenting. Sir is presenting, please.
Remove that.
We can't remove.
Yeah. Okay. Now it's
Thank you.
So we will now discuss about the space technology and Earth system science. There are two different things I have put together. It's very, very important to know because of obvious reason that just one example I will give to the young students. See, in space, actually, we can go, you can collect information about billions of kilometers. But on the planet Earth, we even, have not gone more than 10 kilometers below our surface.
You are muted. You are muted. Please unmute. Dr. Prasant, please unmute yourself. Unmute yourself.
Someone muted, sir, I guess.
Okay, so now you can hear.
Yes, sir, you are absolutely correct. We can hear.
Yeah, I think there is some. Let me just see. Right. But the screen is.
You want it full screen? You want it full screen?
Yeah.
Okay. Is it clear?
Yeah. Let me just put it up. I had kept it in the full screen.
Oh, but it is not a full screen. It was a quarter screen. So I make it. I make it full screen. Is it okay?
You are going to make it?
Yeah.
Yeah, please.
Is that okay? Abhip sir, could you able to see?
Actually, I'm getting the view like the box pattern. So everyone need to pin up sir's account.
Yeah. I have account. I have pinned up the account.
I also have pinned up, but the people over here should pin up the account of sir to get the things very clearly.
Okay.
It's clearly visible, sir. You can continue. No worries with it.
Yeah.
There is another button is also coming about unpin and.
Yeah. It is there. Should I make it enough? Yes, you can start. Now you can start.
Yeah. I'm just trying to.
Yes.
You can see now the full screen.
Yeah.
Now full screen.
And you can listen me.
Yes.
Yes, sir.
Okay.
Absolutely. Yes.
So we will now go ahead. Well, The ISRO, as you know, is one of the pioneer organization in the world and in the India for the three reasons. So one is for making the satellites and the launch vehicles, and third most important thing is the space science applications. So in fact, the Indian Space Research Program or the Indian Space Program is driven by the applications. So we are not doing something for the sake of only for the sake of doing it, but every mission is done with a specific aim and objective to serve the people of this country. And at the same time, in this technology, space science and technology, you know that in the critical areas, not always you get the required help from the outside experts. And that's the reason why the indigenously everything has to be developed from the scratch. And if you, there are pictures, you can see how the modest way Indian Space Research Organization started its work. And those days funds were not available. Our rockets used to be transported on the back of bicycle in Thumpa and also in the back of the bullock cart. Those were the days, late 50s and early 60s. Since then, the ISRO has come a long way, and we have built, hundreds of satellites and hundreds of satellite launch vehicles, which are capable of going to Mars and beyond. And several experimental missions have been carried out, such as the space capsule recovery experiment, going to space and coming back. Then the crew module re-entry. The reusable launch vehicle technology and the crew escape system at the launch pad. So several experimental missions have been carried out. More than 300 satellites have been launched, and that is from not only India, from 30 other countries. So the space transport sector, if you see, we have the SLV started with the satellite launch vehicle, augmented satellite launch vehicle, ASLV, PSLV, polar satellite launch vehicle, and the geostationary satellite launch vehicle, GSLV Mark III, one of the most important rocket for the launching of the communication satellites. So those young students, they may be thinking that, what are the different types of launch vehicles? We require different type of launch vehicles for different of satellites to put in different orbits. So principally there are orbits like the sun synchronous orbit, which is around 700 kilometer. And then we have the 30,000 kilometer orbit, geostationary orbit. That is where our communication satellites go and they stay over there for the communication needs, such as our INSAT series of satellite, Kalpana satellite. And the remote sensing satellites, they normally operate at almost 1,000 kilometer. And we have the Polar Satellite Launch Vehicle, PSLV, one of the most successful and most reliable launch vehicle of ISRO, without failing, which takes the satellite and launches at 1,000 kilometer above the satellite. And using a augmented PSLV, we successfully reached even the lunar orbit, which is approximately 3 to 3.5 lakh kilometers away. So you can imagine that how the mathematical calculation, all those maneuver exercises were carried out. The rocket, which is supposed to go only up to 1,000 kilometer, went almost 3 lakh kilometers. GSLV, this is the future. This is one of the most important satellite launch vehicle. The communication satellite, which are much heavier, weight is around 5 ton. Remote sensing satellite weight is only 1,000 kg or so. Some cases, some specific satellites could be more than 1,000 kg, but it can be as small as few hundred kilograms. So putting few hundred kilograms on a 800 kilometer orbit, you require a smaller rocket. Whereas taking the communication satellite to 32,000 kilometer, you require a much bigger rocket. And that is what the GSLV Mark III is supposed to do. And otherwise, we have to take the help of America, mostly the Europe and the Russian help we are taking. The Ariane rocket name you must have heard, that is one of the world's most successful satellite launch vehicle or the rocket, Ariane, and that is from the European side. And the French Guiana is the place from where we send our the satellites. And at Sriharikota in India, we have one of the finest facility now. We call it the spaceport of the country. There are several, the launch pads are there. So from the launch pad, we can send the rockets one after another without wasting much time. So the country's requirement has increased enormously because those who rule the space will rule the world. I will explain you a little more about it. This is what the recently envisaged by the Elon Musk, of this Tesla success. After the Tesla success, he has hundreds of satellites, and these satellites are going to provide internet connection. That is what the next plan. Tesla vehicle, is works on the battery, and this is initially he had failures. And afterwards, he has tremendous success, and his company is doing very well. And he plans to come to India, and with the aim to launch, this satellite communication. So he says that this laying down the optical fiber cables, what you must be seeing in villages and every town, the different companies digging up our roads and laying down. That is to him, it is a older technology. He wants to communicate to every village through the hundreds of satellites he has launched. So, that's all of the space. It is going to change the way we communicate with the villages, with each other. So indirectly, those who are going to, rule the space are going to rule the world. You will come to know after some time that how important is the space segment. And so that is where, the Indian Space Research Organization can contribute a lot and to meet the requirement of the people. And that is what the success what we have so far. And we are not a very old organization. Started in late 50s and 60s. All the success what you see, it is during our lifetime only. The generation, our generation lifetime, we are seeing all the success. And so now we will look into the, ISRO, as I said, is an end-to-end solution company starting from the satellite launching to the space application. So we don't have many, many organizations in the world who are very, very strong in space application as well as building the satellite, launching the satellite. Some organizations are very good, some countries are very good for making the satellite and launching it. For example, the European Space Agency. When it comes to space application, India scores a point because of our diversity and the size of the country, the population is small. So the most complex, challenging situation we have in our country in terms of the weather, in terms of the, the situation what we have here. So because of that, the space application, variety of space application is so enormous that the amount of complexity our space scientists are facing and solving is, it has put them much ahead of the other space scientists as far as space application is concerned. So building the satellite and launching it at the orbit you require, and also getting the data and analyzing for useful purpose. So end-to-end solution, that is what the ISRO gives. Apart from that, we also have teaching organizations like where I start doing research and teaching to students. And you'll be surprised to know that we have also some teaching programs for the school children. So starting from the school children to the Indian Administrative Service, Indian Police Service people about the space technology application, we almost cover the entire gamut possible in this country, starting from school children to the administrative officers with around 10 to 15 years of experience. Even sometimes, I have given lectures to people to Chief Secretary in Uttarakhand. So So this is what the ISRO enables, that end-to-end solution, starting from building the satellite and to launching and making its application relevant to the cause of the 1 kilometer resolution to less than a meter resolution. We have something like 20 operational Earth observation satellites, which is a very, very big space asset. So many are on the sun synchronous and some are on the geosynchronous orbit. So sun synchronous is the polar orbiting satellite, as I said before, 800 kilometer, 900 kilometer. It will revolve around the Earth. Whereas a geostationary satellite that moves with the Earth at the same speed. So always they will be always at the over our country. So we have resolution which is 1 kilometer to less than meter. So 1 kilometer very coarse resolution, and less than a meter, you can imagine that small car. Sometimes the people can be identified, animal also can be identified using the satellite data when the resolution is less than a meter. That means any object which is just over a meter can be detected, can be seen. And we have the coverage, daily coverage now using a couple of satellites to 24 days, once in 24 days coverage, which is significantly improving every time. And we have also the optical remote sensing, then the microwave remote sensing. What is the difference? Optical remote sensing is like, taking out a camera and taking a picture. But if you have cloud, then the satellite cannot see. Only the microwave satellites, microwave can penetrate through the cloud and still can see the ground, because India is a country where during the Kharif season, particularly during the monsoon time, and we have flood coming, and we have also the agriculture activities that picks up during the monsoon time period, sowing season comes. So during this time, all the time you will find the sky is covered with cloud, and the optical remote sensing will not be successful, and we need the alternate technology which has been developed indigenously in the country. And you also be very happy to know that there are many people, I remember from Odisha, who have significantly contributed for development of microwave remote sensing technology in the country. And so we have the variety of resolution and variety of satellites, variety of technology to tackle the situation and provide the solution. To show you some of the satellites, you can see these, since the Aryabhatta time, Bhaskara 1979, and several satellites have been launched. What is important is, the Cartosat 3 series satellite, US-01, this was launched, a few days back. Cartosat 2S, Resorsat 2, Resorsat 2A, Cartosat 2B, Resat. These are the set of satellites which help us to solve our daily problem and put to various applications, starting from disaster management to the crop monitoring and the urban planning. So you name any application, this can be solved by some of the satellites. So we have the we don't have to depend on foreign countries. All are this is indigenously developed satellites, and they are bringing us the data. And many of the government departments, they get free of cost the data to use for our various requirements. And this is the INSAT series of satellites, which is mainly used for the communication. But smartly, what our scientists have done recently, in the communication satellite, they have also put a camera which can which can take the pictures, and these pictures can be analyzed for various applications such as the cloud movement monitoring, rainfall monitoring, and various other applications. So now the from 32,000 kilometers, normally these communication satellites are at a much higher elevation. That is called the geosynchronous. Orbit, which is roughly 30,000 kilometers. And from there also we can observe, and the powerful cameras which can still observe and provide us data at something like 50 meter, even less than that resolution. So this is what we have. We also have the enough these communication devices, communication satellites, transponders, and many transponders for all our requirement. Now I will take you through the most exciting part of Indian space program's journey since late 50s, that our Chandrayaan 1 and Chandrayaan 2. You can see that the many countries in this slide. The Selena mission of 2008 by Japanese, the 2001 Mars Odyssey mission, then Mars Pathfinder, and we have the Mars Science Laboratory, Mars Sample Return mission. Several missions have been carried out, and this Chang 1 Chinese mission has been carried out for the lunar the exploration, the moon exploration, and India also did Chandrayaan 1 and Chandrayaan 2, and also we had a the Mars orbiter mission in 2013-14 time period. So all these missions, have been they have proved that the technical capabilities and determination of the Indian scientists going to moon, and also proving certain scientific facts which was yet to be confirmed. For example, Chandrayaan 1 and Chandrayaan 2, Chandrayaan 2 data processing is going on right now. Chandrayaan 1 has conclusively proved the evidence of water on the moon surface. So you must be wondering that all these days, all these years, the Japanese and the US and the European organizations, they have been sending the satellites, but still there is, there is a element of doubt, and also it is to be proved that really water exists. If it exists, in what form, whether it is available in the crystal of the mineral, or where it is available in what form. So it is not simply telling that one mission going and telling about the presence of water. We have to substantiate with several evidences, and also you have to find out why the water disappeared today, and what is the reason that the moon doesn't have atmosphere, and our Mars has a very, very thin atmosphere. So what is the role of atmosphere? How did it vanish? If the water was there once, how did it, where did it go? So what is the possibility of finding life on another planet? It's a $1 million, you can say $1 trillion question. The whole world is, trying to find out if there exists life on another planet. And the most important thing to chase life is to chase water. So once you get water, then you can say that the possibility of life could be there, and further studies, and then initiate in that direction. We will see that this is just to show you the young students, how does the the Earth, Moon, and the Mars, they look in physical form, and as far as their size is concerned. And it's very important to look at the history, their evolutionary trend. So all of you know that some of you at least must be knowing the Earth is around 4.5 billion years old, and during our initial time period, there used to be heavy bombardment of the the meteorites. So those actually led to big craters, and all those big craters, which were formed almost 3 billion years ago, or 3.5 billion years ago, on planet Earth. It is very difficult to see because our Earth's surface is very, very dynamic because of plate tectonics. Whereas the plate tectonic doesn't exist on the the Mars and the Moon. So that is the reason those craters, which diameter could be 1,000 kilometer, 500 kilometer, big craters, are there on those surface of Moon and Mars, and they are preserved because of lack of plate tectonics and lack of the atmosphere. So if you want to study what happened to planet Earth 3.5 billion years ago, 3 billion years ago, you have to study the Moon surface and the Mars surface, which tells you the story of which was there during 3 to 4 billion years ago. So that's the reason for evolutionary trend. You need to go to those outer planets, to study it, evolution, crustal evolution, and the mineral evolution, or the surface material evolution, atmosphere evolution. So all have to be known to throw some more light on the planet Earth, and how did life come to existence on the planet Earth, so that we can understand our Earth system much better way. And then in terms of the challenges what we're facing due to the global change and the global warming, we can address in a much better way. So most of the young students, you must be thinking that that whether it is really relevant to understand. Yes, it is relevant to understand in the sense that what has happened on the planet Earth. How did a dinosaur, such a big animal, disappear? If big animal like dinosaur can disappear, we all can disappear, So we have to understand that how to prevent ourselves and what's really going on, that to know about such phenomena in future. So just to give you that what are the situation, and now we'll see some of the craters. These are the most important visible features what you see on the planet, on the moon surface, as well as in the on the Mars surface, and also on the Earth, planet Earth. There are a couple of them. Although we have the plate tectonics and a very, very active atmosphere, still we have certain craters are left, which is still can be identified. We have a lunar crater in India, and there are other craters also people are confirming. They have been attributed to the meteorite or the meteoric impact, and such craters also you find in US and other places, and we find them plenty on the moon and the Mars surface. All that, the lot of rounded depressions what you see on the moon surface, you can actually take a telescope, the young students, and you can see yourself. I think the Pattanaik planetarium, one can go and just in the night you can look at the moon and you will find a lot of those craters. So they are the one which is preserved because there is no atmosphere. On this Earth surface, we have lost them due to the erosion and other plate tectonic effects. You can see the craters on the Mars. They are also present, and this is what also tells us a lot about the evolution of the planet surface on the Mars as well as on the the moon. Another important as the activity is the lava and the volcanoes. So they are present on the Mars as well as on the Earth and the moon, and so this is also contributes a lot to understand about the planetary surface evolution. And moon surface and interior can be understood based on the surface characteristics, and also the lot of physical lot of phenomena which is happening on the moon, and this so-called the moon quakes, like earthquakes. And based on the analysis of data, people have tried to find out what is the thickness of the crust on the Earth as well as on the moon. And moon has a typical difference near side, what the side always the moon, that is called the near side, the far side which we don't see always, and so that's the far side. The thickness of the crust is much more on the far side than on the near side. So this kind of a difference in the crustal thickness is very characteristic of moon. And also the black patches what you see here on the moon surface, if you use a binocular and a good binocular or telescope, you can actually see the black surface. They are the basaltic rocks or the lava flows, and the whitish stuff is basically the anorthosite or the the brighter areas, mostly the mountain or the highland areas. So there the rock property entirely different from the black areas, and these black areas they have the more iron and manganese compared to those white areas. So this tells you very basically, these are the mountains or the highland.
Sorry, you are muted.
Okay.
सर म्यूट हो गला अनम्यूट करंतु
Prasant sir, you are muted. Kindly unmute, please.
How it is happening automatically? It is happening automatically.
That is space problem. That is again space problem. That is again space problem.
Okay. So now we are, is it in slide mode or is in this, which mode is this? That is again we are back to the square one situation. Okay, if I, sorry. Yeah. You can see it now, you can listen me and you can see it.
Yes,
Yes, we are able to see you and listen you also. Dr. Prasad, go ahead.
Yeah. So the evidence of water, what you can see on the moon and Mars, and there are sedimentary rocks on the Mars as well as on the the Earth. So they look so similar. So it clearly tells that once water had flown, the river channels and other things what we see on the Earth's surface today, the similar things also we see on the Mars. So this gives us a lot of information that the situation was something similar to planet Earth, some time back. And how did it become such a place without any without any significant amount of water, liquid water? Because all those rocks will form only when the water flows. This is called the sedimentary rock. So class 8th our students must have studied how does the igneous rock, sedimentary rock and the metamorphic rock forms. So sedimentary rock will form if the water flows and the sediments come from one place and get deposited. So that indicates that water had flown once on the Mars surface, and why did it stop flowing now? Or it is still flowing? We are not able to observe it. So a lot of scientific questions keep coming all the time, and that is what the scientists.
Sir, again you are muted.
Someone muted him. And I also, I don't know what happened to my phone.
I'm not doing it at my end.
Yes, sir. Yes, sir. We got to know the problem. We are solving it soon.
Okay. Right. So let me just put it again back to. And it is always going to. Now, using there is a satellite called Clementine. The topography map of the moon was first time prepared, and you can imagine that sitting on planet Earth, we could know exactly every point, what is the depth of the point or height of the point through the satellite mission. So, this shows the power of technology and how detailed information can be obtained. And you can see the entire area, the iron percentage also could be mapped, could be known. So I was telling you those black areas on the moon surface, left side is the near surface and the right side is the far surface. So look, let us concentrate on the near side. The near side, you can see those black places, what I had shown you before, they are now red, basically showing the more of iron. The lava or the the basaltic rocks, they have more of iron and manganese compared to the other rocks, granitic rocks. So that's the reason why you have those the black spots appearing red, indicating the higher iron. So the basic question is, why study the moon? As I have said before, we want to know about the early history, the active geologic forces, including plate tectonics and erosion, and we want to know about the evolution of Mercury, Venus, and Mars based on their individual crater records. Then photogeologic interpretation of other planet is based largely on the lessons what you learn from the moon, because that is our closest celestial body. Mission Moon and Mars is driven by the chase water and chase life, as I said before. That's the reason why the missions are being designed. It is not for any pleasure going to Moon or Mars. It is to prove a point. We want to discover new things. We want to make sure that our understanding improves about the planetary evolution. Chandrayaan-2. Some of you must be thinking that when the lander failed on 22nd of July, that everything is over. You also saw television channels showing, all that Prime Minister going and ISRO chairman breaking down in front of all of you. But there is a silver lining. We had a lander and a rover. Rover is working perfectly and it is providing all the data what was required to understand more about the, the Chandrayaan, about the lunar surface. What Chandrayaan-1 actually, whatever it gave us the information and the knowledge, we wanted to continue, And Chandrayaan 2 is fulfilling that, providing much more information than what was possible with the Chandrayaan 1 in the beginning. And Chandrayaan 1, you know, there are many sensors were all given by the foreign companies or the foreign institutions through collaboration, whereas Chandrayaan 2 is a totally indigenous, and all the payloads are all indigenously developed, and the data now is being analyzed to know about the, you know, to know much more about the lunar surface characterization. So Chandrayaan 2 is not a failure. It is providing the data information from our orbiter, which is working perfectly fine, and it is working even better than Chandrayaan 1 orbiter. Chandrayaan 1 was orbiter mainly. So you can imagine that the way it was portrayed, that we failed to land. Of course, we failed to land, but that's not the full story. We will look at some of the missions. So initially it was planned like this landing system will be commanded for its controlled descent from the polar orbit. That is where things went wrong, and we didn't have a good landing. And we will see that a lot of efforts have gone in to make the terrain mapping camera very, very systematic subsystem of the terrain mapping camera will give us 5-meter resolution entire lunar surface, which is even till date we have not done for our entire area of Earth. We have not done this kind of high resolution mapping, and we are planning to do. It's going on actually. Data acquisition is going on, and everything is going as per the plan. So entire moon surface will be mapped at 5-meter resolution using a very systematic, camera which is operating at 100-meter, 200-meter, very, very close orbit. The orbit can vary depending on our requirement, and all the data will help us to know about all the hills relief. So you must be wondering that all that Clementine had done, then what we are doing more, because Clementine had done a resolution much, much lower compared to our TMC, which is going to give us very, very high resolution information, and the whole world community is looking forward to that information. Then in the name of my institute, there is called the Imaging Infrared Spectrometer, one system which will provide us the information from 400 nanometer up to 5000 nanometer, or 0.4 micrometer to 5 micrometer. This will tell us about the characteristics of lunar material on the surface of the moon, and also the geological, the minerals present there. How did they form? Where do they come from? All that information can be obtained once you analyze this imaging infrared spectrometer. So one system, which is very, very unique. It was never, there is no system exist like this system, even by the other organizations. So starting from 400 nanometer, the spectral range, electromagnetic range. So in the electromagnetic range, starting from 400 to 5000, at every point, a material will have a different signature. H2O or the water will have a different signature at different places, the different the spectral the band. So that is the reason why we are trying to do this, because we want to characterize the different type of materials, identify the water also very, very conclusively. Then we have L-band and S-band synthetic aperture radar. Synthetic aperture radar will work very nicely in the areas which are under permanently shadow condition in the north and the south pole of the of the lunar surface. So like our polar region, for 6 months they are dark, and 6 months only light comes. So same thing happens in the moon also, and you cannot observe using optical remote sensing satellite or sensors. So you have to have microwave remote sensing radar. So this L-band and S-band again designed by us, by our scientists only, and to provide the information, and they can penetrate the, they can operate in the darkness of the shadow and try to find out if there is a presence of water or the ice. Then we have alpha particle X-ray spectrometer and several other sensors to know about the material constituent and the atmosphere. Now, Chandrayaan 1 also had the similar payload, TMC, terrain mapping camera. Sorry. we had a hyperspectral imager HIC and the lunar laser ranging instrument for determination of the height directly. These are all the Indian missions, Indian sensors, and also we had a lot of instruments given by the foreign collaborators. So you can see here a lot were contributed by the people from abroad. But Chandrayaan 2, most of the things are done. All the sensors belongs to India. This is a moon mineralogy mapper. It was provided by collaborator from NASA, and using this this sensor, we could find out what type of minerals are present on the lunar surface. So very meticulously the data could be analyzed, and very very minutely all the constituents, mineral constituents could be known. Just imagine that we have not gone to moon, but we are able to know very very precisely what type of mineral is present there, and how did the mineral come into existence. So all those evolutionary trends could be known. This is a piece of work what was done by us and our team. And if there's a crater, and as you move away from the crater, how the mineral constituent is varying, we could also know that. This is a very interesting finding. You must be thinking that I am showing you certain things which has been done by the others, and certain things which has been done by my own team and our own team over here. So we could find out a couple of craters. And I spoke to, during our different seminars and conferences, I spoke to the person who had given that mineralogy, moon mineralogy mapper MQ. Her name is Carly Peters. She works in Brown University. I asked that you have been working for the last 30 to 40 years. What is left for us to discover? She said that, very little we have done. She is a topmost scientist, space scientist from USA, and she accepts that very little they know and there is a lot to know. So that is what she encouraged me to take up this kind of study. So the ISRO, the advantage is that when you are in ISRO, you will be able to meet the top class scientists of the of the world. And what matters is not somebody's big scientist or small scientist. What matters is the science, what you are talking. So it's not that the color of the skin or the place you come from, it doesn't matter. Everybody is same. On this kind of the platform what ISRO gives, or the global platform, and what matters is what you speak, and it's nothing to feel shy, and we don't feel any shyness. So that is something, the confidence which has given the ISRO, and I would say confidence also partly given because of our journey from the modest village, Ankoi, Delang. When Namita told, I come from a small village, and that has actually motivated that you fear none, respect all and fear none. And when it comes to science, we have the capability to challenge the best in the world. Although we may not, we have the capability to compete with the best in the world. I never say that I want to defeat the best, but at least we have the capability to compete with the best in the world, the business what we do. So this is what, just to show you that you talk to people and you have learned a lot from them, respect them, and then also you try to prove certain points which they have not seen so far. They will be surprised, and they will also acknowledge your contribution in the field of science using the Indian sensors and satellites. See, finally is the taxpayers' money we are utilizing, and unless we come out with something new which is not known to the world, how do we justify the enormous amount of funds which has been utilized by ISRO for sending a space vehicle to the lunar surface or to the Mars surface? So we are answerable, to the scientific community as well as to the taxpayers in this country. So very, very meticulously, the same thing has been done to find out the Fe evidence, how the Fe percentage in different types, different places of the lunar surface. And we we have used the technique because we have not gone to moon, and a lot of samples has been collected by the Apollo mission and previous moon mission. So those samples have been analyzed, and exactly at that spot, we try to find out what is the spectral signature. So analyzing the spectral signature, and then we try to find out, we set up an equation and try to find out how much, the iron is there. So is there any, helium is present? So you can go and bring couple of kgs of helium, which will generate a lot of power on the planet Earth. So the whole idea is that, the characterization of the surface, knowing about the surface, knowing about the chemical composition of entire surface of the moon without, collecting a sample. This is what, is a very innovative thing to do, and using various combinations. See, the world science is converging in the sense that Apollo samples are so expensive. You cannot get a 10 grams is so expensive, and total actually they got something like 400 kg, and everywhere in US they are all distributed in the labs and the museums they are kept, and so you cannot get sample just like that, to analyze. So we take their data and the methodology. Then finally we apply it on our satellite data. So it's a combination of technology, what they have done and what we have done together. We analyze, and then we come out with the results, and that results we compare, and also we publish and present before the experts, global experts, so they acknowledge that yes, this is true, and this is a direction to take to know more about the surface, lunar surface characterization. Now coming back to the Earth system, it's very interesting. Earth system is a very closed system. Nothing goes out of Earth system. So it's 4.5 billion years old. Only planet presently known to support life. We have, our life has thrived and has well-defined continents and ocean basins, very dynamic, both internally and externally. It's a closed system. Very interesting. Nothing goes out of Earth. Nothing comes in, nothing goes out. Very few meteorites only. They only come in. So it goes to evaporates and comes back. So class 9, 10 students must be knowing about the water cycle. Every drop of water gets evaporated and finally it comes back as the rain. So, so also everything. So we will look at it, and there are problems. So what we are facing on the planet are the energy and the environment and disaster. There are three things which actually affect us, right? So Odisha is a state which is known for disasters, and the energy, we don't have sufficient energy to light every village, every home in the village. Environment, many people are telling that environment is deteriorating day by day. So we have challenges with respect to energy, environment, and disasters. How to manage disaster, how to live with disasters, minimize the effect. And so we have, hurricanes in Florida, the 2010 floods in Pakistan. So it is happening, So did not introduce disaster to the people from Odisha or those who are, India, who've been locked into this presentation. But interesting thing is, for every problem there is a solution waiting to be found. The problem cannot be, solved by thinking within the framework within which the problems were created. That's what the Albert Einstein has said. We have to look beyond, and external view is required. So that is what is the space technology gives you, that we look the flood from, from different angle, or the earthquake from different angle. We'll go to that. So the four spheres within our closed system, we have the, the geosphere about the earth, and the crust, and the hydrosphere, the water, atmosphere, the air, and the biosphere, we are part of the biosphere, the human beings and these, all those plants. So energy and matter are exchanged between these components, and in this, of course, so we can, we are part of the biosphere, and our interaction with this different geosphere, hydrosphere, atmosphere is critical, and as has been deliberated by various international experts and all, how we influence in the second half of these, the 20th century and 21st century, first part of the 21st century, how the human beings are influencing this, these spheres, geosphere, hydrosphere, atmosphere. So the dynamic geosphere we have the plate tectonics. All of you know, it's very, very unique to the Earth, which is not seen on the planet, other planets, and that's the reason why the mountains are built. And to some extent, also there is a thing, there is a going on by the hypothesis, the life is created because of the plate tectonics. So it's very interesting. You can see some papers and how everything is linked to the plate tectonics, and that is also eventually is the reason that if you look at the Indian plate and Eurasia plate, Indian plate is moving towards Eurasia plate at a certain speed. And if you calculate the speed, you will find that after say maybe 60 million years, the Indian plate won't be there. Our country won't be there. So we might have to move to China or make some other place our country. So let us look at this plate tectonics and mountain building. These are all intricately related to each other. Plates are continuously moving, and that's because of the Eurasia, Indian plate hitting the Eurasia plate. We have the the giant Himalaya, and when the plates collide, slip by one another or pull apart, enormous forces cause rock to break and buckle, and that is what causes the earthquakes. We will see. So that's the region wherever the plate boundary is there, a lot of earthquakes are also there, and that's the same place also you have the the volcanoes. So volcano and earthquakes, they all they are together, and you can see the northern part of the Indian plate. That is where the Indian plate is hitting the Asian plate. That is where Himalaya has formed, and a lot of mountain building activity is happening. Himalaya is rising. The Himalayan region was once upon a time a sea, and today it is 8,000 kilometer. It is 8 kilometer in height. So which was there once upon a time, maybe a couple of kilometers below the sea level. So that is the effect of the plate tectonics, and the number of earthquakes we have in the last, say, you can say 1,000 years or so. Enormous number of earthquakes have occurred in the Himalaya. On every day, actually, we get earthquakes, and so also the other plate boundary situation. And you can see here the U.S., particularly the western U.S., California and San Francisco area. You must be seeing the Hollywood and all those places are actually very, very vulnerable to the earthquakes, and also Japan. So all the developed countries and areas are also vulnerable to earthquakes and tsunami. And that's the reason we want to understand this phenomena much better way using the space technology. The ring of fires or the volcanoes are also there. Very interesting things happening all around the plate boundaries. And these plate boundaries are to be understood thoroughly. What is their speed? What is there and how do they move? Is there any variation across different seasons, or it is constantly moving? Indian plate, we have read from the childhood that Indian plate is moving at rate of 5 centimeter. So 5 millimeter, say 50 millimeter a year. So 50 millimeter a year means approximately you can say that every week we are actually moving 1 millimeter towards China. So you can calculate our Kanyakumari, how long it will take to go below the, Indian plate is actually going below the Eurasia plate at the Tibet. And you can take the finger, you can all of you young students can do a calculation that if every week we are moving 1 millimeter and Kanyakumari distance from Himalaya, say around 3,000 kilometers, how long it will take for the Kanyakumari to go down the, Tibet. So you can do a calculation, it will come around 50 to 60 million years actually. So that shows that is our, that after that we have to find another place. Anyway, by then, as Indian plate moves, we will be moving here and there and we will be finding, some other continent to live on. Now, this is what we had heard from people, that the Indian plate is moving at certain speed. What is the speed? We wanted to know it. So this is what I say, that we have to put our instruments, and I wanted to know from childhood days, my college days in IIT, and those days I was hearing this. The Himalaya formed once upon a time, it was the sea, now it is a mountain. How did it form? What is the speed? How the Indian plate is moving? We just wanted to calculate ourselves. How to calculate? So we put some instruments. So ISRO provided generously grant, and we put the instruments, and these instruments require certain kind of, instruments come from US, from Switzerland. The software comes from US, and all that work has to be done here. And then the data processing has to be carried out by our scientists. To get a training, to process the data, also Herculean task. And our people had to work day and night to process the data, and finally, without anybody's help. Very proud to say that yes, people have helped, but it's not that significant help. But our people, some Indian students, they work day and night and to process the data and give us the velocity. And when we saw the velocity, and we're very happy that first time we calculated ourselves 50 millimeter or 49 millimeter or 60 millimeter, what is the rate at which the Indian plate is actually moving? Not only the Indian plate, we also got data from Australia and the Eurasia and Africa, Tibet region, there are stations. This instrument data is now being shared by the global community, and we process those data and we come to know what's really happening. Now I'll show you very interesting an Indian plate. We have our own 2 instruments in the Himalaya, and this red line shows that how our points are moving, our Hyderabad and Bangalore points, how they are moving. And this gives us in millimeter that all these places, Delhi, Roorkee and Dehradun, and so they're all moving at 48, 30. As you go deep into the Himalaya, the rate of movement reduces because, there is a resistance from the Eurasia plate. So there's some kind of collision is happening. So initially it is going at a high speed, then it is slowly reducing the speed. And because of the reduction in the speed, we have a lot of strain is building up, and this strain is released once in a while in the form of earthquakes. So that's why in the earthquake or the earthquake hazard map, the Himalayan belt is the highest hazard prone area, zone 5 we call it, zone 5, and Delhi and other surrounding places are called the zone 4. And in Odisha we have zone 2 and zone 1, Mahanadi basin, that is partly zone 3, and then the rest is zone 2. So these are less vulnerable to seismic or earthquake hazard, which is zone 5 and 4 are very, very vulnerable to seismic hazard. And that also corresponds very well on this measurement. Very high speed movement is seen and gradually decreases towards the Himalayan region. And very interesting thing happened when we fixed our location, Dehradun location, and tried to see the Indian plate. We found that Indian plate is moving towards, when you fix our location and then try to see relative movement, the Indian plate showed some kind of a anti-clockwise motion towards towards east. This anti-clockwise motion was not known before, and that is one of the reasons that why I'll show you another one. And the Asian plate is actually Asian side, Tibet side is moving towards clockwise. We are moving anti-clockwise. In the northeastern part of our country, we have a very interesting collision. It's a much more collision than this simple translational movement. We have a rotational component also. So because of the rotational component, we have seen northeast of our country. It has experienced the largest magnitude earthquake ever seen on the planet Earth at this place. Because you have a translational motion, and on top of that, we have a rotational component also. It's a the double-edged sword effect. So this was also a discovery kind of thing. Unless we analyze the data, we wouldn't have known actually the real reason for northeastern part of our country, why it has emerged as the the highly vulnerable place for the earthquake. 1950 and 1897, 2 big earthquakes occurred, close to 9 magnitude, and many people died, and that place is highly vulnerable even today. That is mainly due to this kind of 2 type of motion, and 1 type of motion was known, but the other type of motion was not known, and then this became a part of new knowledge. German scientists actually had postulated that Indian plate is not only moving in a straightforward manner, there is a rotational component. So they had used paleomagnetic studies to know this thing. They are great scientists and they had done this thing, but they were not having the present measurement. But what we provided the actual measurement observed on today. So that becomes again another unique contribution. This is how the Indian plate is moving. You have a bit of an anti-clockwise motion. That is what is, we are having anti-clockwise motion. I'll show you now. And not only this anti-clockwise motion also, leads to some kind of a drainage shifting in the Himalaya towards east. So suddenly you will find a stream moving towards, eastern direction. So from the flood hazard point of view, you have to be very, very careful. You have agriculture field on the eastern bank of the streams coming from the Himalaya. You have to have, you have to invest a lot of money to protect that land. Western side, it will not go. The stream will not go. It will only move towards the eastern side. So a small finding tells us that where I should do the disaster management, where I should protect my land, or if I have to construct a house, where I should take more care. Because of the geodynamics, the plate motion finally leads to, the river migration from the Himalaya. So this is very interesting. And the rivers, all their crazy things happen when the streams come out of Himalaya. They all move in left, right direction, but there is a certain pattern to it, to that chaotic situation, what we see. So we studied on the ground these old satellite data, new satellite data, and also this GNSS, the movement. So all that put together, we concluded a story that really the eastward motion is a critical part, one which was not known before, and it became a significant finding, new knowledge for the scientist. And very, very minutely, we went to the field, to the jungle and forest area, and tried to see why a stream is moving in a crazy manner, why it is supposed to move in a straightforward manner, but suddenly it is moving towards east. So, there is also, we'll try to see agriculture field. People have lost a lot of agriculture field, which is on the eastern bank of the river. Western bank is safe. So they also don't understand why western bank is safe, why the eastern bank is getting affected. So disaster managers also can learn a lot from this experience. Then very interesting thing, looking at the whole thing, we try to find out how did the Saraswati vanish? Some scientists don't believe that Saraswati had once flown, right? Ganga, Jamuna, Saraswati. So how did the word come Saraswati from? So was there any real Saraswati? A lot of people have done this space-based study and they found out that yes, Saraswati was there and it was flowing through between Ganga and Yamuna. It was flowing, through the Thar desert, and it was flowing into the Arabian Sea. And such a big river, how did it vanish? Question is that. So as I said, nobody had a clear-cut answer. How did the river vanish, such a big river? Now, this geodynamic study, after doing the geodynamic study, we found a reason that how the small development at the frontal part of the Himalaya can change the river course. Again, this became a new finding also. So then how did we call that, Allahabad or now the Prayagraj? So it is called the Triveni, Ganga, Jamuna, Saraswati. So people say, the Saraswati river is Patal Rachi. Saraswati river is not there in the, in Patal. Saraswati river is captured by actually the Jamuna. The name Jamuna is very interesting. Jamarajra Kanya Jamuna. In Bangladesh, when the river migrate too much, the Brahmaputra and the Ganga, they migrate too much, they behave in a crazy manner. People also call their Jamuna. Jamuna means the one which takes life. So it doesn't, the Lord Jamaraj is not considered a very kind God, that's why his daughter is very naughty and takes life. So that's why wherever the river migrates a lot, the name is given Jamuna. So which is given by the ancestors, the people, that tells a lot about the character of the river. So what has happened in the India, the Jamuna actually has captured the part of the water of Saraswati. So the original course of Saraswati became dry. All that water of Saraswati started flowing into the Jamuna. So that means what Jamuna brings water of Saraswati and Jamuna, and Ganga brings water. So at Prayagraj, it became a Triveni. You have to find the logic why it is called a Triveni. It is not that Patalarachi Saraswati. Name is Triveni. This is a scientific reason. And again, this came from our discovery that how did it happen. And it's not only our discovery, also it was also by one British scientist, Oldham. His name is Oldham, brilliant scientist. He also had hinted, and 1880s, he had also written an article which I happened to read. 1880, he has read he has published a paper. So in geology, you have to read literature which is as old as 18th century. Always I study literature which is 17th century literature. From here and there, you can try and get it. 19th century and literature, 20th century literature, you have to see and correlate with the current situation with the help of the latest technology. So we move forward and backward something like 100 years, 200 years, 500 years, and sometimes billions of years in geology to find out why did the Saraswati vanish, why did the dinosaur vanish, extinct on the planet surface. So we are almost coming to end of our time, 5:30 or so. Yeah, this is what I had shown you before, that how the Tibet plate is moving and how the Indian plate, collision is happening. It's very interesting. A lot of studies Chinese have done, and that clearly tells how this part is arrow mark. If you are able to see on your screen, how the arrow mark is moving towards, in a clockwise manner. And we actually, this is, they have not discovered yet the anti-clockwise motion. So that's why they have not shown it here. They have only shown the clockwise part, and we added our, our thing, anti-clockwise. So we are moving in anti-clockwise motion. They are moving in a clockwise, and that is leading to a huge collision in the northeastern part. So all crazy things, that's why has happened in the northeastern part of our country, and a lot of mountains, the deepest gorge on the planet Earth is actually Namcha Borua sector, that is in our northeastern part. 5 kilometer deep gorge, 4 kilometer deep gorge Brahmaputra flows through. Can you imagine? Width is only 100 meter, 200 meter. And the gorge where the river is flowing, like Satakusia Gando, where the Mahanadi passes through. Have you gone? You should go and see, what is a gorge. Satkosia Gando jaiki dekhiba katha. And similarly, just imagine that 4 kilometer deep gorges are there, through which the deepest gorge, that is only possible because of this geodynamics, what we have understood. Now, all that, can it help to understand the earthquake precursors? Earthquake precursor means some advance warning related to the earthquake which is coming. Now, the Einstein's, what he has said, that you have to be away from the problem to solve a problem. So the earthquake is basically Earth-related thing, but we moved to the atmosphere, ionosphere. We wanted to study what is really happening to ionosphere before an earthquake. Very interesting. And many people had postulated, many theories were given, they were challenged. Many were banned in other countries to do this kind of study. Some Japanese friend, actually professor, which is 85 years old, I know him, he was banned. US, NASA also, some people were not supported. But in India, luckily, we were supported by the ISRO to do this kind of study, to find out in the disturbance in the ionosphere, can it lead to get advance warning about the earthquake. This is one of the most important finding which we came across. I know the instruments I have put for the crustal movement or the Indian plate motion, same instrument was used to find out the ion concentration in the atmosphere, in the ionosphere. The total electron content. Daytime it increases, nighttime it decreases. There is a certain pattern. Now, this pattern has a upper bound and the lower bound. Physics professors can understand very well. So the ionosphere is like a, it goes up during day and comes down because of the solar interaction. So electron content, without those electron content, telecommunication cannot happen. So for the telecommunication to happen, we have to have a lot of charged particles in the ionosphere. Through ionosphere only the communication, the global communication happens. That's why they monitor very, very, minutely. They monitor the ionosphere, for the communication, global communication. Now, these data also we try to analyze to find out, is there any variation before an earthquake? There is a regular systematic way it varies. So we know what is the upper bound, what is the lower bound. Then we try to find out if this lower bound is crossed or upper bound is crossed any day before an earthquake. And we found some differences. Then there is a professor, I'll move there and okay, so little story. Then there's a professor in NASA with whom we have some collaboration. He also did an experiment, applied too much of pressure to a rock. Then he saw that current is flowing through the rock when he applies too much of pressure. Very interesting finding. And his name is Friedman, Friedman. So 1970s, he was doing PhD. He found a defect in a crystal. That defect is responsible for this kind of current flow. You see, he was never related to the earth science or anything. He was doing a crystallography physics PhD. And after that, he continued and he found that if you apply too much of pressure to rock, बहुत pressure पकेले ता मझे current flow करे. And it's very interesting experiment he carried out. That experiment actually became the the main thing which we implemented in our case. And there was also a Taiwan scientist working on the ionosphere, how the disturbances in ionosphere can lead to earthquake. Then I had a Japanese, a French scientist who is a good friend of mine. We discovered that from the ionosphere he could find out the magnitude of the earthquake. He did a very good mathematical models and formulas he set up. So there are people from Taiwan, people from Paris, from NASA, and from India also. Some people had earlier worked. The instrument I used actually comes from Switzerland and some from US. And one of a scientist from Bombay, Indian Institute of Geomagnetism, he had gone to Japan for a postdoctorate. He had developed a computer program. That program we used. So everybody's thing we used put together. There was a European scientist called Pulinet, and his ideas also we used. So you can see how many ideas were converged together. Gitare kuhaichi. If you have good idea from anywhere, you should accumulate and utilize for your purpose. If you have, there's a nice saying. Actually, I was editing a Odia magazine. Always I put that thing on the at the front. That good knowledge and wisdom can come from anywhere, and you should accept it. And you should be ready to, with folded hand, you should accept those good knowledge and the wisdom. That is what Gita teaches us. We utilized. So from Taiwan to NASA, Europe, and all this knowledge we brought together to find out very, very interesting, which has never been before so far. You are seeing for the first time. So with our instrument data, we found out there was an earthquake in Nepal in 2015. And this, prior to that earthquake, we saw some kind of anomaly in our total electron content in our instrument. So those days we had two instruments closer around 600 kilometers away from the the place where the earthquake happened. And later on we got a lot of data from Nepal because American agencies are working there. They have similar instruments. Initially they had not given us the data, but afterwards they gave, and we analyzed their data to know more about it. So same type of anomaly also we got at two locations, one in Dehradun, one in the Bhubaneswar. And then very interesting, the global data also we analyzed, and we saw some kind of anomaly very, very close to the epicenter before 14 days. So ideally before 14 days, we could see there is a disturbance, and the center of the disturbance was very, very close to the epicenter. That means what theoretically, you can actually know the earthquake is coming and it is where it is coming. The plus or minus, we had an error of 277 kilometer epicenter of earthquake because the data resolution is very, very low, what we used. Finally, from Nepal, the US agencies, they shared the data. California Institute of Technology, Caltech, one of the, the premier institute in US, they gave the data we analyzed. So our accuracy improved to something like 50 kilometer, 35 kilometer. So that means what 14 days before, I can know the earthquake is coming, and with an accuracy of plus or minus 35 kilometer. This became a global finding. So you just see where we started. Like a baby step, we took the baby step. We did not know anything about the data processing. We bought the instrument. Luckily ISRO gave us money. So each instrument cost actually 15 lakhs, something like 16 instruments I have. We had a project of 5 crore. And it was the highest amount of money ever I handled to set up an instrument. And there was no other study to refer to. So it was all trying to find a pin in a haystack, and all our students, around 50 students worked, and many of them worked actually day and night to process the data. Right now also every day we process enormous amount of data which comes from our instrument to find out is there any early indication. Yesterday only, day before yesterday, I told we have seen a similar thing, and we expect an earthquake in Himalayan region within up to February 5th. So 15 days ahead, we know now we are just waiting that earthquake have to happen because similar signature we have seen. So the very interesting things, I think will not go further, and I will conclude here. Similarly, we have done a lot for the Kedarnath disaster, and a lot of modeling has been done, and we try to find out what actually happened in the Kedarnath 2013 when 5,000 people died. The root cause of the Kedarnath disaster was also found out by our team doing a lot of modeling and analysis. So that was also another success story. So now coming to the students, young student, the most important thing in space image analysis is the image interpretation. Photo dekhikiri photo chitra ru kichi kichi janiba. So this requires ପିଲାମାନେ ସବୁ ଜାଣିଥିବେ ଘର ମାନେ ଯୋଉମାନେ ପଢନ୍ତି ଟେବୁଲ ପାଖରେ ଗୋଟେ circle concentric circles they draw to improve their concentration. All the students, all the young and old. So this is what is required to improve your concentration. If your concentration is very, very high, you can do a much better image interpretation. So image interpretation is looking at the picture for hours together to find out what is that thing, unique, what you are seeing. I will show you now a nice picture. Okay, it's a test. Those who are listening to me, now there is a tree. Now you tell, what are you seeing in this tree?
2%.
Okay, Namita says
4%.
6%.
There is 7.
carefully, look carefully.
All the famous
Somebody
Sir,
said
there are
nine.
the pictures of some freedom fighters.
Yes,
10% are there. 10.
yes.
okay,
Look at these faces, you know them very well. Even though you know these faces, you took so much of time,
Yes,
right,
yes.
to identify each face.
Lal Bahadur Shastri.
Bal Gangadhar Tilak, Mahatma Gandhi, Rabindranath Tagore, Bhagat Singh.
Okay. So this shows that, is something which appears like a tree. It is actually a combination of human faces.
Yeah.
So image interpretation is like this. What we see, we try to find out what rock is there. What is the geological structure is there? What is the mineral present? And that too on the moon surface, on the Mars surface. So this is how we learn the technique of image interpretation, and that we apply to moon and Mars to tell about the story evolution. So it's a combination of your visual interpretation, mathematical calculation, and the instruments what you require, everything put together to resolve or to discover new things. So it's a fascinating journey what I have gone through, and many of you will get that chance. Look at this IRS. So this is in Dehradun and not too far. So there are a lot of courses for the young students, and we have a UN center also here. You can join many courses, and some of you, if you can get through the UN center, you will get a fellowship also. It's very good fellowship you get to for 1 year to do a course here, and all the teachers, they are encouraged to come to IRS for a special course which you organize for them. Again, we pay the travel, and also we pay some stipend also, travel support, and some money we give for the teachers during their holidays to come and study. Young students also can come. We also sponsor their visit to IRS, and there are a lot of web-based courses, online courses, free of cost. You can also attend. All government officers can attend our courses free of cost. We don't charge money. But our students, those who want to attend, some are free, but some are chargeable courses. You can visit our website, and that is where you learn the image interpretation. And once you master the image interpretation, image analysis, digital image processing, you can choose a career in computer science, you can choose a career in space science, you can choose your career in disaster science also. Okay. So with this, I come to end, and there are some questions which can be, which we need to answer for this kind of course. So, how did the Earth form in the solar system, and how did the crustal evolution take place, and what scientific input could be provided by planetary studies using Indian missions? You can answer those questions. Is there any hope of getting precursory signal to earthquake? So now the answer is yes, there are signals. And why can't we predict the next rockfall or the landslide in the Himalaya? So that science has developed, it is always possible. And why do extreme precipitation event, extreme rainfall event takes place so frequently in Indian subcontinent, and it is more and more happening. The maximum amount of lightning happening in Odisha only. Globally hotspot of lightning, Odisha. So one need to study why it is happening, and why and how did the Himalaya other mountain ranges form? And for example, our Odisha Eastern Ghat, how did it form? Eastern Ghat? How did Chilika form? So all those questions should come to mind. So young mind, you should only ask questions, looking at the places, your village, you go to a village, see some unique feature and ask, well, how did it come to exist? So all those important things, you should keep asking questions so that to find the answer, you will go a long way, and it will also professionally and personally very, very rewarding, and also it will contribute to the global Indian science as well as the global science. So thank you very much for the wonderful opportunity what you gave me, and I try to do justice. But Namita ji, all that you have said good things about me. I don't know whether I fulfill or not, but a simple person try to share my experience with the all the youngsters and with all your faculty members and teachers and the respected your chief guest and college principal, vice principal. So thank you all for patient hearing and giving me this wonderful opportunity. Thank you all.
Okay, very nice, very nice. Now, there are so many hands raised by boys and girls. One is Saubhagya Jena. Would you like to ask anything? Yes, Saubhagya Jena?
Yes, ma'am.
Yes. Introduce yourself, Saubhagya Jena. Kids of Saubhagya, I think. Yes. Saubhagya ra puo bote. Introduce yourself, Saubhagya. Master Jena. Yes.
Good evening to you all. Myself, Preeti Pragya Jena, student of Kendriya Vidyalaya Vyasanagar. I am expressing my sincere thanks to Dr. Namita Pattanaik on behalf of my parents because she is the teacher from philosopher of my father for arranging such a tremendous webinar. Also, I am expressing my thanks to all dignitaries present here. On this topic, I would like to clear my doubt from Dr. Prasant Kumar Champati Rai sir, scientist ISRO. My question is, when the mission of Chandrayaan will be completed?
Chandrayaan 2 is right now going on, and the Chandrayaan 2, the life can be minimum 5 years. That is what is expected, and so we have launched in 22nd July 2019. So you can add 5 to that. So 2024, and also it may work for another 5 years. Depending on the liquid propulsions which is stored there and the health of the satellite. So as long as it is there, it will provide us information, and this information will be analyzed to find out the presence of water. That is one thing. Characteristics of the water present on the moon surface, and the spatial distribution, where are the water present and how much is there. And also the mineral characterization, surface mineral characterization, what type of minerals are present. So inch by inch will be studied, geomorphological features will be studied, and also the places where most likely we will land next time when we go. So which is the most suitable place for landing, or if the humans have to go there for experiments, so which is the most important site for doing such experiment. So those areas will be found out. So there are numerous objectives. So primarily it is into 3 categories. One is about the water. Second one is about the mineral characterization. A third thing about the geomorphological characterization or the terrain mapping, accurate terrain mapping. So 3 things, 3 targets, 3 main objectives are there. And during the course of data acquisition, which is our Chandrayaan 2 will do, and we more and more data we get, more and more better analysis we can carry out, and hopefully up to 2025 it will work and provide us the data.
Another my personal question is, why maximum scientists in ISRO are from South India?
Oh, it is basically local effect. They see they see the ISRO centers around them, and they get more interest, and so it is because of that they join. Mostly they join. But it's not like that. Anybody else can also join ISRO. So we have also a lot of people from North India, East India, and western part of the country joining ISRO. So it is a local effect, I would say, because they see those institutes and they have their parents guiding children, encouraging them to join ISRO. So that's the reason more number of people have joined from ISRO. But any population you take, there are equal intelligent people are present, so which is around 1 to 2% of any population you take. So it's not the North Indian or South Indian or anything like that. It's always 1 or 2% people who will be intelligent for this kind of thing. And if they're motivated to join scientific organization, they will join. So this motivation is more in South India compared to the other part, because other part of our country, intelligent people go to other professions. Punjab, you will find, they will do the farming. Many will go for the even educated people and very intelligent people. They will choose to do the farming or go abroad, Canada and US. So it all depends on the society, what society prefers, what parental pressure, and then it gradually, becomes your aim and objective in life. But if you are determined to join ISRO, always you can join ISRO or the organization which is working like ISRO, space science. So space science and technology. So anybody can join, and there are many organizations and a lot of opportunities exist.
Thank you.
Thank you, Master Jena. से होची मोर स्टूडेंट सौभाग्य जेनार पुओ माने एते खुशी से मान सब पिला माने और केते जण पिला अछंती क्वेश्चन पचारिया पे मिस्टर अभिजीत आर देयर
Ma'am, I am the daughter of Saubhagya Ranjan Jena.
Oh, sorry. Oh, daughter of Saubhagya. Okay. Great daughter of great son, na? Father, great father. Acha, Abhijit, are you there? Student from physics. बहुत क्वेश्चन थिला अभिजीत रो. Abhijit, are you there? Mr. Bharun? Mr. Bharun?
Yes, I am here, ma'am.
Yeah. He is from Jharkhand. Do you have any question, Bharun?
Ma'am, I am actually residing in Chhattisgarh and basically I am from West Bengal.
Yeah.
But I am born and brought up in Odisha.
Okay.
So, diversified character actually.
Okay. You understood Odia? You can ask
Yes,
in
yes.
Odia.
Okay. What I wanted to ask, sir, if there are any program launched by ISRO to reach all the remote places of our country so that many more students will be interested towards science.
Yeah, we have our, tele-education program, and also we call it distance learning program of ISRO. It is launched by IARS. You can visit our website and you will see many such courses are there. And you can join these courses, and most of them are free of cost. And you can learn. So it's very simple. You have to register and join.
Okay, sir. Thanks very much. Actually, I learned many things today. A lot of questions were in my mind regarding tectonic plate movements, which to some extent I was able to clear my doubts. Thank you very much.
Okay, welcome.
So we have visited many places, starting from Arizona to Dehradun and so many places. So now I would like to request Dr. Maharishi Das, who has already written, God bless you, Dr. Prasant. Prasant, feeling proud of you. Your smile is very, very unique. God gifted talents you have. So my request, Dr. Maharishi Das, sir. ଆପଣ ଯଦି ଦି ପଦ କହିବେ ଆମେ ଖୁସି ହବୁ ସାର୍ ବହୁତ ସୁନ୍ଦର ସାର୍ଙ୍କର ଭାରି ମୋଟିଭେସନାଲ ସ୍ପିକର ସାର୍ ଏବଂ ସାର୍ ଥରେ ଆସିଗଲେ ଭିତରେ ପଶି ଯାଆନ୍ତି ସେ ଆଉ ବାହାରିକି ଯାଇପାରନ୍ତିନି ତେଣୁ ମୁଁ ଭାବୁଛି ଆଜି ଟିକେ ସାର୍ ଆପଣ ନିଶ୍ଚିତ ଭାବରେ ପ୍ରଶାନ୍ତ ଭାଇକୁ ଦି ପଦ କହିବେ ଆଶୀର୍ବାଦ ଦେବେ
ଆଚ୍ଛା ଡକ୍ଟର ପ୍ରଶାନ୍ତ ମୁଁ ଖାଲି ଗୋଟେ ପଚାରୁଛି ସେ କଣ ୟୁନିଟ୍ 1 ବଏଜ ହାଇ ସ୍କୁଲ ଷ୍ଟୁଡେଣ୍ଟ କି ଡକ୍ଟର ପ୍ରଶାନ୍ତ
नहीं यूनिट 3
अच्छा अच्छा हो
कैपिटल हाई स्कूल
ନାଇଁ ମୁଁ ତ ମତେ ବାନ୍ଧି ପକେଇଲେ ଯେ ଜଗନ୍ନାଥଙ୍କ ଡୋରି ଟାଣିଲା ଭଳିଆ ଏଠି ନମିତାର ଡୋରି ପୁଣି ଅଭିପ୍ସା ମତେ ଟାଣିକି ବାନ୍ଧିଦେଲା। ଆଉ ଖାଲି ଗୋଟିଏ କଥା ବହୁତ ଶୁଣିଲି, ଆଉ 3ଟା କଥା ମୁଁ ବି ଲେଖିଛି ଏ ଚାଟ୍ ବକ୍ସରେ ଯେ ଡକ୍ଟର ପ୍ରଶାନ୍ତ ଯୋଉ କହୁଥିଲେ ମାନେ ମୁଁ ଆଜେ ମାନେ ସାଇକୋଥେରାପିଷ୍ଟ ଦେଖୁଥିଲି ତାଙ୍କର ଯୋଉ କଣ୍ଟିନ୍ୟୁଅସଲି ଗୋଟିଏ ୱେଭଲେନ୍ଥରେ ଗୋଟିଏ ହସ, ଭାଇବ୍ରେସନ and the conviction and the totally the involvement ମାନେ ପୁରା ଭିତରୁ ଆସୁଥିଲା which a scientist because I started my career as a scientist in 1975 in Cuttack Central Rice Research Institute. So your style is unique and you are really dedicated. I am praying God to give you that strength and to give you that conviction power. Yes, we are doing something. Really, I am touched. God bless you. I am giving a ATM card. Put a ATM card for permanent. As and when you require, you can put it, use it, and get the blessing of Lord Jagannath. That is the ATM card for Lord Jagannath. That is it.
Thank you so
Last
much.
is ମୁଁ ଖାଲି ଗୋଟିଏ କଥା ଆମେ ଯୋଉଟା ଆଥର ହଉଥିଲୁ ମୁଁ ଡକ୍ଟର ପ୍ରଶାନ୍ତ କହିବି ଆମେ ମଣିଷ ଯୋଉ ତିଆରି କରୁଛୁ ସାଟେଲାଇଟ ଉପରକୁ ପଳଉଛି କନେକ୍ଟ ସେ ସବୁକୁ କନେକ୍ଟ କରିଦଉଛି ଆମେ ମଣିଷ ଗୋଟିଏ ପରିବାର ଭିତରେ ରହି ବାପା ମା ପୁଅ ଝିଅ ଆମେ being present but are not being connected. ତେଣୁ ଆରି ଉପରେ କେବେ ରିସର୍ଚ୍ଚ ହବ everybody will be connected to each other emotionally, morally ଏବଂ positively, creatively, intellectually କେବେ ହବ ସେଇଟା ହଉଛି being connected. Satellite connect କରିଦଉଛି ଏଠି ବସି ଅଷ୍ଟ୍ରେଲିଆର ମ୍ୟାଚ ଦେଖୁଛୁ ପୁରା ବଲଟେ ଯାଉଛି this is the burning because when you come back home after office, when you come back home, definitely you want to be connected with your wife, children and parents who are staying. That is getting connected and that is real space. How Namita, I am blessing.
Thank you very much, sir, for kind words. Thank you.
दिल से निकलता है and you are speaking ମୁଁ ଦେଖିଛି ପ୍ରତ୍ୟେକ ପାଖରେ ଟ୍ୟାପ ଟାକୁ ପାଖରେ ଧରି ଆଚ୍ଛା ମୁଁ କାହିଁକି ଏଇଟାକୁ ବର୍ତ୍ତମାନ ଭିଡିଓ ଅନ୍ କରୁନି କାରଣ ମୁଁ ଧୂପ ଦଉଥିଲି ପୂଜା ଡ୍ରେସରେ ଅଛି God bless you ରହିଲି ଆଉ ସ୍ପେଶାଲ ଆଶୀର୍ବାଦ ଅଭିଷା
Thank you so much.
ରହିଲି ସେଇଟା ତମେ ତ ମାରି ବସିଛ ଆଗରୁ ଆଉ ରହିଲି ଜୟ ଜଗନ୍ନାଥ
ସାର୍ ନମସ୍କାର ସାର୍ ସାର୍ ନମସ୍କାର ସାର୍ ନମସ୍କାର ଜୟ ଜଗନ୍ନାଥ ସାର୍ ମୁଁ ଗୋଟେ ପ୍ରଶ୍ନ ପଚାରୁଛି ସାର୍ ଟିକେ ମୋର ଇସ୍ରୋ ଅନୁଷ୍ଠାନକୁ ଆମେ ଯାଇପାରିବୁ କି କେତେବେଳେ ଭିଜିଟ୍ କରିପାରିବୁ ତାର କ୍ରାଇଟେରିଆ କ'ଣ
Anytime आप visit କରିପାରିବେ particularly during launching time और rocket launching ଦେଖିବାକୁ ହେଲେ ଆପଣ ଆମର ଯୋଉ public relation officer ତାଙ୍କୁ ଚିଠି ଲେଖିବେ ସେମାନେ ବି ସୁଯୋଗ ଦେଇପାରନ୍ତି ଆପଣଙ୍କୁ launching ଶ୍ରୀହରିକୋଟା ଯାଇକି ଦେଖିବା ପାଇଁ
ସାର୍
it is always possible you can write a letter particularly young student ମାନେ ଯିଏ ବି ଆପଣ ଲେଖନ୍ତୁ ଚିଠି ସେମାନେ they will make some arrangement
ସାର୍ ଆମେ ଟିଚର ହିସାବରେ ପିଲାଙ୍କୁ କିଛି ନେଇପାରିବୁ
ଟିଚର ହିସାବରେ ଆପଣ କୋଇ any ISRO center you can go and you can visit any ISRO center
କେତେ ଦିନ ପୂର୍ବରୁ କଣ୍ଟାକ୍ଟ କରାଯାଇ ପାରିବ
ଆପଣ ମାସେ ପୂର୍ବରୁ ଚିଠି ଲେଖିବେ
ହଉ ସାର୍
ତାପରେ ସେମାନେ ଆରେଞ୍ଜମେଣ୍ଟ କରିକି ଆପଣଙ୍କୁ ଜଣେଇବେ ସାଙ୍ଗେ
ସାର୍ ରହୁଛି ସାର୍ ଜୟ ଜଗନ୍ନାଥ
ଓକେ ଜୟ ଜଗନ୍ନାଥ
ନମସ୍କାର ସାର୍
Is there any other question? Anybody else? ଆଉ କୌଣସି ପିଲାଙ୍କର କିଛି କ୍ୱେଶ୍ଚିନ୍ ଅଛି କି
ମ୍ୟାମ୍ ସାର୍ଟିଫିକେଟ
ହ୍ୟାଲୋ ସାର୍ ହଁ ସାର୍ଟିଫିକେଟ ମିଳିବ now I request Abhipsa to show the certificate. Their certificate, your certificate is very well present here. ସମସ୍ତଙ୍କ ସିଗ୍ନେଚର ହେଇଛି ଆଉ କାଳି ସାର୍ ମଧ୍ୟ ପରମିଶନ ଦେଇଛନ୍ତି ଯେତେ ଜଣ ଜଏନ କରିଛନ୍ତି ସମସ୍ତଙ୍କୁ ଦିଆହବ नो ଫିଡବ୍ୟାକ୍ ସୁଲୋଚନା ମ୍ୟାଡାମ ଫିଡବ୍ୟାକ୍ ମାଗିଥିଲେ ଆପଣ ମାନେ ଆମେ we believe scout believe in trustworthy so scout ସମସ୍ତଙ୍କୁ ବିଶ୍ୱାସ କରେ ଆପଣ ମାନେ ଜଏନ କଲେ ନଲେଜ ନେଲେ ଏମ୍ପାୱାର ହେଲେ ଆଠୁ ବଡ କଥା କିଛି ନାହିଁ ତେଣୁ ମୁଁ ଅନୁରୋଧ କରିବି ଟିକେ ଅଭିପ୍ସା ସେୟାରିଂ କରିଦେଉ ସାର୍ଟିଫିକେଟ ସମସ୍ତେ ଦେଖି ଦିଅନ୍ତୁ ମନ ଖୁସି ହେଇଯିବ
Hello, sir.
Thank you. Rasmi, yes, Rasmi, you have question. One of our alumni from physics department, Rasmi Rautara, please. Please, you can ask.
Please.
Hello, sir. Good evening.
Good evening.
Sir, we do have a telescope, CPC 1100, and with that we have seen the craters of moon. Can we see with that the Neil Armstrong footsteps? As we know, there is no environment around the cloud, and
you can see footstep. But the only thing is your telescopes, should be resolving power should be good enough. But you can know exact spot. You can Google it, and you will also know exactly the footstep location. And there is a photograph also of the footstep, and the exact location you can focus in a good moonlit night, and hopefully you will get it.
Sir, I do have a question. Japan do have all major volcanoes. Do you measure the volcanoes before that rise?
Volcano, see, the study is going on. We have only one volcano, that is a barren island in our near Andaman Nicobar Island. So before volcanic eruption, we are seeing some earthquake activity. But that is we are trying to find out how to know when the volcano is going to erupt. Can it be known? So about the height of the volcano and all, that is we are not trying to know right now. We are trying to find out when the volcano is going to erupt. So that is the important question we are trying to know.
So most of the cities of Japan is being destroyed by these eruptions. So can we detect before that the eruption?
Yeah. Now there are technology. Now in Italy, we have some many organizations are working, Japan and Italy. So to predict the volcanic eruption, and they are reasonably successful. So recent time, the death due to volcanic eruption is reduced significantly. I don't think anybody dies because of the volcanic eruption nowadays. So few people only, those who ignore the advice and all, unfortunately, they get involved in the volcanic flow, they get trapped. But that number is very, very less, and there are techniques it can be predicted now. And we are trying to find out another way of predicting that based on our volcanic, barren island volcano, that area also having a lot of earthquake. We have seen before the volcanic eruption, earthquakes do take place. So what is the relation between earthquake and volcano? So that we have tried to find out in recent time. Our team goes to visit the volcano, and we have carried out some studies there. Some more studies are required. So then we will have also a new thing to establish the link between the earthquake and volcano in barren island area.
So in future, can we make a technology that reduces the effect of cyclone? Because the Odisha is most probably the most wanted state of cyclones. So can we, as a third law of physics, every action has equal and opposite reaction. Can we make a technology that will reflect or reduce the effect of that cyclone?
Yeah. Very, very interesting question. What is now the global community, scientific community is working to know about the landfall time and the place of the cyclone. Then accordingly they will take the preventive measures. So the idea is that to know about the landfall and the time. And
So your technology has achieved it. Before 15 days or 14 days, you predict it or tells about the cyclones and earthquakes. But
it is prediction of earthquake is not so simple and straightforward. Reason is that I told all the atmospheric parameter you can study using space technology, whereas below the earth, what is happening We don't know more than 10 kilometers depth. The deepest well we have drilled only up to 10 kilometer. So below 10 kilometer, what is there we don't know. Whereas in the space, we know entire 300 kilometer of atmospheric, our atmospheric column, we have the information. So this, due to lack of information on the crust and the mantle, upper mantle, we have the problem of predicting the earthquake. So we don't say now we have a technology for predicting the earthquake, because prediction means you have to tell about the magnitude, time, and also the place. Three things you have to tell in very, very accurately. What we are able to tell now, that there is a indication of earthquake and it will happen one of the days within 15 days and plus or minus of 30 kilometer or 500 kilometer depending on what data we have used. So it is only to some extent some success has been achieved. So it is not like cyclone. Cyclone, you have much more success we have achieved exactly within plus or minus 100 kilometer. Funny and Phylline cyclone, we have clearly said the error was within 50 kilometers. Timing also almost perfect came. So cyclone we are reasonably success because data regarding cyclone is easier to get than the data due to the earthquake. So please don't be carried away that earthquake prediction is possible.
No.
Still a big challenge.
So sometimes scientists told that the decibel of that earthquake that happened, the amount, the
Mishra, now you recognize? Mishra, now you recognize your friend?
Sir, namaskar.
Namaskar, namaskar.
Mihir bhai is our
Mihir Kumar
friend.
Jana. My question is, what is space
Okay, Mishra.
station?
What is?
Space station.
My question is, what is space?
Space debris.
Agent in space.
Space debris.
What is space station? And how many space stations are present
What we
in
know,
space?
the space station.
Space station.
Mishra, ଆପଣ ଟିକେ ଲେଖିଦିଅନ୍ତୁ chat box ରେ.
Sir, namaskar.
Namaskar, namaskar.
Sir, Jai Jagannath.
Jai Jagannath.
Sir, ମୋ ଘର ବି ପୁରୀ।
Oh.
ଆଉ sir ମୋ ନା ପ୍ରଣତି ଜେନା ଆଉ ମୁଁ ମିସେସ୍ ଚନ୍ଦନ ପଡାଙ୍କ ମିସେସ୍।
Okay, ନମସ୍କାର।
sir ମତେ ଲାଗିଲା ମୁଁ ଘରେ ବସି ଇସ୍ରୋ ବୁଲିଗଲି sir।
ସମସ୍ତେ ବୁଲିଗଲେ।
sir ବହୁତ ଖୁସି sir। ଜଗନ୍ନାଥ ପାଖରେ ଗୁହାରି କରୁଛି ଆପଣଙ୍କର ଉତ୍ତରାତର ଉନ୍ନତି ହଉ sir। ଆହୁରି ଆପଣ ଆଗକୁ ଯାଆନ୍ତୁ ଆମେ ଏମିତି ଦେଖୁଥାଉ ଆପଣଙ୍କୁ sir।
Thank you so much. Thank you very much for all your blessings.
ପ୍ରକାଶ sir କିଛି question ଅଛି କୁହନ୍ତୁ unmute କରିକି। DAP Kalinga Nagar Prakash sir, Dr. Prakash Panigai. Would you like to ask any question, Prakash sir? Okay. Mir sir, आपना question clear हेलानी? Okay. Mir भाई, ଆମର Dr. Mihir Saran, Mihir Ranjan Saran, Prasant भाई, ଆମ classmate, Mihir Saran, Department of Physics ଆମର senior lecturer ଅଛନ୍ତି। ମୁଁ ତାକୁ surprise ରେ କହିଥିଲି, ମୁଁ କହିନଥିଲି ଯେ କିଏ ଆସୁଛନ୍ତି, just come and see, watch, ତାପରେ ଦେଖିବୁ। ତ ଏତେ ଖୁସି ଲାଗୁଛି, we are friends are here in the same platform. And now it's time, Abhishek sir, ସମସ୍ତଙ୍କ ଟିକେ certificate ଟା present କରିଦିଅ। Then on behalf of Maharishi College and Odisha State Bharat Scouts and Guide, I'll request to present the memento.
Madam, one minute, madam, namaskar. Sir, namaskar.
Namaskar.
Sir, namaskar.
Puri loko kuhantu.
Myself, Dr.B.K from Puri, assistant teacher, Uttarana School, Puri district. Sir, I am very glad to meet you in this webinar. I just want to know, sir, how many space stations are working now?
Okay, that figure I do not have right now. So many countries they have tried to do, but successfully. We know about one space station which is working very successfully. So one space station, and other countries are also. One is the International Space Station, what we know, and others are also trying. Yes.
Yes, sir.
But
Thank you, sir.
maintaining a space station is a difficult task. That's the reason why we send a orbiter, or orbiter you can call it. So that goes much more closer to the target like Mars or Moon or any Jupiter, and it can provide a lot of information. That's the reason why it is much more cost effective, and to send an orbiter. Like satellites are moving around Earth at 600 kilometers. On the moon surface, because of the low gravity, because on Earth actually very difficult to run a satellite at 100 or 200 kilometers, because it will be pulled down because of gravity. Since gravity is very very low on Moon and Mars, you may not have that much pull, so you can operate a satellite at a much lower elevation. So when you operate a satellite at lower elevation, you will get much more detailed information about the surface without facing problem of falling down. And that becomes very helpful that, year after year, day after day, we can collect a lot of information to understand the whole dynamics of the planetary system. डे टाइम रे बहुत धूली झड़ हुए मार्स रे बहुत डस्ट स्टॉर्म धूली झड़
Yes, sir.
केतेबेले होची केतेबेले कमुची कोन में होची कोन में कमुची all that possible after analyzing.
Hello, sir.
Okay.
Is
Okay, sir. Thank you, sir.
most of the
Sir,
lightning
ଟିକେ
Odisha?
बहुत खुशी होती सर हम इसरो ଟିକେ बुली आसले बहुत खुशी लागन सर हमको.
You can nearest station is best is go to Sriharikota.
Yeah.
Sriharikota माने आपण जिबे चेन्नई पाखरे. Then you can visit also our our ISRO center and know about the launch pad from where the satellite is launched. Or you can visit our NRSC Hyderabad. There is a big center, Ahmedabad. So wherever you go, any big city you go, you will find a ISRO center, and you just have to plan in advance. And before 15 days or so, you write a letter you want to visit, and they will facilitate your visit.
Okay, thank you sir. नमस्कार सर.
नमस्कार.
ସାର୍ ବର୍ତ୍ତମାନ ସୁଦ୍ଧା ଅଛନ୍ତି ଅଫିସ ରେ, ତେଣୁ ଶୀତ ଦିନ ଡେରାଡୁନରେ ବହୁତ ଶୀତ। ସାର୍ ଯିବା ପୂର୍ବରୁ ଆମେ ତାଙ୍କୁ ଆମ ତରଫରୁ ମୁଁ ଅନୁରୋଧ କରିବି, ସାର୍ ପାୟଲ ସାର୍ ଅଛନ୍ତି, ଆଗ ଅଭିପ ସାର୍ ସମସ୍ତଙ୍କ ସାର୍ଟିଫିକେଟ ଟା ଟିକେ ସେୟାର କରିଦିଅ, ସମସ୍ତେ ଟିକେ ଦେଖି ଦିଅନ୍ତୁ, ସମସ୍ତେ ବହୁତ ଅପେକ୍ଷାରେ ଅଛନ୍ତି ସାର୍ଟିଫିକେଟ ଟା ଦେଖିବା ପାଇଁ। You just share the certificate, then I'll request Kali sir to present the memento.
This is the certificate you will be getting for attending the webinar. So please don't worry, be with us. We'll be getting the certificate soon.
ସମସ୍ତଙ୍କର ସାର୍ଟିଫିକେଟ ବହୁତ ଆଶା, ସାର୍ଟିଫିକେଟ କେମିତି ମିଳିବ, ନିଶ୍ଚିତ ଭାବରେ ମିଳିବ। ଆପଣମାନେ ଏତେ ସଂଖ୍ୟାରେ ଯୋଗ ଦେଇଛନ୍ତି। ବର୍ତ୍ତମାନ ଦୁଇ ଜଣ ମୋର ଧନ୍ୟବାଦ ଦେବି। ପ୍ରଥମ ଧନ୍ୟବାଦ ଦେବି ଇଞ୍ଜିନିୟର ଚନ୍ଦନ ପରିଡ଼ା। May I request Chandan bhai, will you please come on video please, unmute your video please Chandan bhai। यहाँ का पाई मुझे पूर्ण बंधु को पाइपली Chandan bhai is the alumni of our college. Mir bhai, Dr. Mishra, could you able to listen to me? Mir bhai, आज Chandan bhai हमारा होचंती प्रणति मैडम का हस्बैंड जैस्मिन गारी होचंती इंजीनियर। से होचंती हमारा फ्रेंड तो किस चंपती राय सर। तेणु से जेते बेले हमको आंख सहित मीट कराई देछंती, सो थैंक्स गो टू हिम। सो आपण बड़ मानक तरफ धन्यवाद देबे मीर भाई, हमारा लेफ्टिनेंट एनसीसी ऑफिसर सब लेफ्टिनेंट हमर फ्लाइंग सब लेफ्टिनेंट अछंती एनसीसी रो एयर विंग रो चार्ज रे मे सर अनुरोध करी से धन्यवाद देबे एवं से चंदन सर को निश्चित भाव रे आग धन्यवाद देबे एवं समस्त धन्यवाद देबे ऑन बिहाफ ऑफ द webinar I'll request Abhipsa Parida who has taken all the pain to organize all sort of sharing and all the things which helped me a lot to reduce my time in sharing. So, Mir sir धन्यवाद दे सार पल्ला परे मो अभिषा को अनुरोध करिवि से धन्यवाद दबो beforehand. I will go to over to Mir bhai Dr. Mihir Ranjan Saran, senior lecturer in physics, Maharishi College.
मैडम नमस्कार सार को सहित किसी कथा ही हबो कि
यहाँ के कहतिले शिव भाई ब्रजेश सर
ब्रजेश सिंह को जाजपुर रो
ब्रजेश सिंह जाजपुर ओके हां डू यू हैव एनी क्वेश्चन
सर क्वेश्चन नहीं मो सार को अनुरोध करबी हम स्कूल थरे हम पिला को भेटिबे सुदर्शन पड़ी हाई स्कूल चैनपुर
अच्छा
इनवाइट करियो जण कोन से बड़ा प्रोग्राम ऊपर
ऑनलाइन रे ना डाकी फिजिकली
सर फिजिकली हम स्कूल सिल्वर जुबली हबार अछि तो हमें अनुरोध करिमो सर आसीबे
sure you can take the phone number and address.
Thank you very much.
Yeah, very nice.
सर मु अछि पारा स्पेशल फोर्स आर्मी रो अछि
ओके
स्कूल पे चेष्टा करछि ब्लॉक ग्राउंड स्कूल हम जाजपुर अछिटा तो ताकू बतन लड़ी नंबर 1 स्कूल करिया पे जाजपुर रे तो आपण केबे बड़ा प्रोग्राम रे आसीबे सेति सर मैं आशा व्यक्त करिवि सर
ओके थैंक यू वेरी मच
ब्रजे भाई मोटू नहीं दिबे सांगर ईमेल और फोन नंबर so that you can have a contact before time sangu janebe. Now over to Mir bhai Dr. Ranjan Saran.
Good evening everybody. Hello Dr. Prasant Champati sir. I think you will recognize me. We are the classmate in IST. Could you recognize me now?
Yeah, okay. Lot of changes. Your hairline has gone back.
Yeah.
It's a customary to share thanks. So on the behalf of Bharat Scout Guide, somebody is giving thanks. And on behalf of the Department of Physics, Maharishi College, the principal. Thank you very much for sharing such a beautiful knowledge about the remote sensing and particularly about the satellite and our Pattanaik plate movement. It's a really fantastic thing, and I hope that all our student friends and young and old, definitely they have got a very classy knowledge about these things, because so many people, they are interested in visiting ISRO, because after getting this knowledge, definitely they can take the since you have enlightened them very nicely. So on behalf of the principal and Department of Physics, Maharishi College, I thank you very much. Thank you, sir.
Thank you.
And at the same time, I also thank our Kali Prasanna sir, because
Kali Prasad,
Mr. Sir, he is the very high post. He is holding the National Vice President, State Chief Commissioner. So I don't have any say today. I am really grateful to you, sir. So you have associated our physics department with this Scout and Guide webinar. So because it's a amalgamation of both the things, science and the discipline of the Bharat Scout and Guide. So thank you very much. And particularly Namita madam, he is taking lot of pain and conducting webinar in such a manner that so many students, they are interested and taking part in this webinar and enlightened by this various professors, scientists. So it is a nice thing. So I also, on behalf of the Department of Physics, Maharishi College, I thank you. Thank you all the audience who are very patiently listening it, and it's though the time is over, but still they're asking questions. So Dr. Prasant Champati sir, he very nicely explained everything. But sometimes what happens when we talk about the Earth, it is some Earth and space. It is so infinity. So again, we can call you for some more topic in the webinar in our physics department. So Dr. Champati definitely will give some time so that we can invite you for another webinar in the Department of Physics. Thank you all. So, Namita,
Thank you very much.
Thank you all.
Now I request Abhishek. Would you like to say first or share the memento to sir? Which one you like, Abhishek?
Kali sir is not here.
Okay, I'll do. So by the time you finish your
I want to share a thank you slide for especially for Prasant Kumar Champati Rai sir.
Sure. Please share your thoughts. I'll talk to sir. Yes, over to Abhishek.
Yes, ma'am.
मिले हो तुम हमको बड़ी मुसीबतों से चुराया मैंने लकीरों से तेरी मोहब्बत की प्यासे सदा रहना मिले हो तुम हमको बड़े नसीबों से चुराया है मैंने मत की लकीरों मिले हो तुम हमको बड़े नसीबों से चुराया है मैंने मत की लकीरों
Thank you.
Thank you so much, sir. I'm excited to have you with.
Very nice. Thank you so much.
Okay.
Thank you.
Okay, thank you. So we'll go through now. Over to Avishka for sharing the memento for our son. Remember us. Presentation of memento.
Really, sir, we are very much enlightened to have you with us. And seriously, we thought like we visited the whole universe through you, and not required that we should visit ISRO because you are with us, no? Our Odia Poor and our really pride of Odisha, and really, sir, we are proud of you. So kindly receive a small token of love from Odisha State Bharat Scout and Guides and the whole family of MCNL.
Thank you so much. I am right.
Can you just share the memento for Kalisa, Chief Guest?
Yeah, sure. This is for Kali Prasad Mishra sir, our pioneer, our patron, and obviously the National Vice President and State Chief Commissioner. We are really strength. We are having strong. We are strong in strength because of Kali sir only. So thank you, sir, and do accept this from us too as a token of love. From your family only. We are all your family only. Thank you, sir.
Thank you, presence.
Very nice program. Thank you.
Okay. So let us say bye to, not goodbye, bye to sir.
Okay, bye-bye and take care. Thank you very much.
Once again, mail file request raila hame puri thare bank to paiba. So now yes sir. Anything?
Definitely, sure. We'll be in touch. Okay, bye-bye. God bless. Take care.
I'll ask all of you.
Sir, one more thing. I want to
yeah.
Sir, Abhishek Patel is none other than your friends, doctor, sir. Chandan Patel does here.
Okay. Very nice to see you.
So this is the Avipsa and Siva Babu. All of you salute. Salute to the guest. Yeah. Siva Babu, thank you very much. Once again we'll meet. Thank you very much for giving your time, your energy, all that things. Thank you very much.
Thank you. Thank you. Bye bye. Namaskar.
I'm now going to stop the recording, otherwise it will go. Yeah. Just wait. Stop streaming. Yeah. Okay. Stop recording.